Hello guys, I think we are live. I think the stream is good. Welcome, welcome. Today we're gonna go greedy again. Our focus will be on understanding the greedy topic and greedy subtypes because each greedy problem can have different approach. Um, so today I want to focus on the last subtype, which is this color. we're gonna we're gonna solve all of them basically. And today we also have something enjoyable and fun to use. All right, we're gonna use this counter, and in the first 10 minutes, we're gonna try we're gonna think about it, think about the possible solution approaches, and then for the remaining 20 minutes, we're gonna chat with AI and we will basically study together with AI's guidance, using AI guidance. All right. Um, yeah, I think we can start. We also have this arena you can join. Um, Here's the room code. You can share your code, your text and images and everything you wanna share, and we can review. We can view in the stream. Um, all right. I think we are good, right? Let me once more check the setting. Yeah, yeah, it looks nice. So the question is this, and we can also start the timer. I guess I have started it. All right, which is wonderful. Our question is this. Let's see what we have here. Like we've seen this, like we've studied this question actually before. Mm, Let me. All right, press enter. So I can make it a bit smaller, I think. All right, wonderful. A Vigo sequence is a sequence where the differences between successive numbers strictly alternate between positive and negative. Wonderful. That's a good um, description. The first difference, if one exists, may be either positive or negative. A sequence with one element and sequence with two non-equal elements are trivially Vigo. All right, all right. For example, is a Vigo sequence because the sign is basically alternating, guys. Sign is alternating, like a positive, negative, positive, negative. In contrast, mm, are not Vigo sequences? Yes, because they don't alternate. The first is not because its first two differences are positive, and the second is not because its last difference is zero. Oh, wait a minute. We are getting differences. Differences between I thought the question is about um mm, like a sign, but it's not about signs. It's about differences. So six means the next character, the next item will be six more. And here, for example, -3, and here it will 5. Here it will -7. Here it will 3. So the number of elements we have here is 6, but the differences we have basically 5. So one less, one less. Um, all right. So a subsequence is obtained by deleting some elements from the original sequence, leaving the remaining elements in their original order. All right. So given an integer array, return the length of the longest. It's been 2 minutes, guys. Longest wiggle. Mm, So we have this word here, longest, the longest. Return the length of the longest wiggle subsequence. So we're gonna try finding subsequences that, you know, preserve this rule basically. But how can we? What should we do? Like, um, all right, let's put it here. What should we do, guys? Basically, we need to calculate the differences. Basically, like this is one process, right? We need to do it. This is unescapable, you know. We're gonna do it. We're gonna process the uh, differences. Let's say we have differences table or array, all right? And then what? Like this is first step. The second step is imagine we have differences table. Then what? Then what are we gonna do? All right. Let's see. Let's have a minus one, two, and minus three, and one, right? So one way is like drawing the decision tree, but what are like we need to decide what our options are basically, right? So um basically like we have this array, but this array may not be, you know, fully correct. Like I mean this, at least this subsequence may not suffice the rule. Maybe this subset is all right. Let's see. All right, maybe this. So we don't know which subsequence. So subsequence means we can remove an element, but the order of remaining ones should be the same. So we can extract a number basically, or multiple numbers, but the order should be. So for each character, we can either, you know, insert it into our subsequence. So maybe like maybe this is not our decision tree, but instead, for each element, for example, for minus one, we can insert. I mean, use or don't use. Maybe these are our options, right? For minus one, and in the next level, for two. Like this is brute force, obviously. And also, how can we validate? How can we validate that we like? Hmm. Like after maybe we can apply some pruning, right? Maybe we can apply some pruning so that we don't even explore a bad decision or a bad path, basically, right? Because as we go one level deeper, the element we are processing, or yes, the element, because we have the difference array. So the element we are processing should, like the sign of the element we are putting, like we are trying to insert, should be different than the previous one or previous level, basically, right? So since the sign is different, we can insert it. We can insert it, but we have two options. Like we can insert or we don't insert, basically. Like it is available, but we have two options. But let's say we had minus two here, all right? Let's suppose we have minus two here. So in the previous level we have minus one, and the sign is same. So basically, the one and only option for us is to skip. So use or don't use, or let's say skip. All right, use or skip. So for minus two, we have like if the sign is same, we just skip basically. All right. If the sign is alternating, now we really have two options. We can insert it or don't. Why? Because maybe inserting it may cause a problem, because then even the next character after that, maybe should maybe a wrong one, and it may be a number which can reduce our longer possibility basically, so that skipping it might be the better option, might be the better option, yeah, might be a better option. So let's say we have -2 and 3, and then let's say we have 5 and -7, let's say. So when we are processing this one, it's going to be 10 minutes or so um while we are processing this 3, which is positive, right? No, like, let's say if it is, if it is positive, guys, I mean it is alternating, the best option is taking it. Like, we don't earn anything by skipping it. But I thought maybe the next character is positive. If the next character after 3 is positive, like, we there is only one option that we skip. And if the next character is negative, then it is still good because it's alternating. So we don't earn anything by skipping basically. Maybe this is why this question is greedy basically. Um, it's gonna it's it's gonna be 10 minutes, guys. So, like, this decision tree helps me understand our options basically. All right. Um, so for the alternating sign, there is no option. We literally pick it. If it is same, and well, I mean, if the sign is alternating, there is one like there are two options, but one is superior basically, and basically no regret, right? Like something like that we had in our previous stream, like uh, a choice that will not harm us basically, right? Um, so picking the alternating one never harms us, so we pick it basically. So this is the greedy, I think, in this question. But of course I don't know how we can create the this array, but it is easy. We can create, like, we can initialize a new array with the length -1 length, and then basically using a for loop we can, which starts from 1, we can get the first element, and then we, subtract our I minus, actually we can make it like a prev equal to 0, and we can use prev here. All right, r mine prev. All right, and assign this to the new array, alternating array. uh, I-1 would be great. All right, so that this is the way how we create this array. And we also, like, observed and you know examined basically that picking the alternating one never harms us. So this is the good approach, I suppose. So now we can talk with AI, and let's see. Hello, I hope you are doing great. Now we are solving this wiggle question, and I figured, like, I assumed for a second I know how to create the alternating array. All right, it's a process. And given that we have, this alternating array, now we need to define our available options, right? And I try to draw a decision tree, and, like, in each level we basically use the character or skip the character. Like, it resembles to like a knapsack problem, right? Knapsack 01 problem. For each item there are two options available for us: use or skip. I mean, include the element, include the item into our solution or not, or skip it. And in the next level, as we go deeper in our decision tree, if we have, let's say, alternating character, alternating item, we like choosing, like including it, is superior and is no regret, because we examine different cases, and there is no harm with picking the alternating item. It doesn't hurt us. So maybe this is the greedy part. um so we also talk about pruning, all right. um so that, for example, for not alternating one, maybe I should also, like, we should also examine not alternating case, because, like, I learned that drawing this decision tree helps us to locate where the greedy part lays, all right. But sometimes it may be untrivial, all right. Maybe hard to see, because I thought the greedy part is here is like, if the alternating character, we should definitely pick it, include it, because it doesn't harm us, so it is no regret. um but for the not alternating case, what are our options, basically? Now, we're gonna think about the not alternating case, and what should we do in that case. Like, is there something obvious? Like, is there something obvious choice? So for not alternating case, um of course we should skip it, because we cannot include it, all right. um yeah, we should skip it, definitely. So there is only one option. There are no choices to discover, basically, right? So when non-alternating comes, like in our decision tree, I don't see it, like we don't see it, but there is only one option. But, like, for example, like another example where like the translating our options and using our options, and eliminating or pruning the obvious one. Like, there is another question where we compare two strings, all right. And actually we have talked about this in our last stream as well. um we talk about, like, if the characters are matched, there is only one obvious choice. We move, like, a pointer 1 and pointer 2 forward. But in our last stream, you showed us that even for obvious ones, there is a proof behind it, so that we eliminate our other options. Because even for matching case, we can move again pointer 1 or pointer 2, or we can move both of them at the same time. These are our options. But one of them is obvious, because it is guaranteed. I mean, I don't know, like something like that, all right? You showed us this. So, um, obvious means you have proof that the other options is not, you know, suitable for our case. I need, like, can you please clarify on that? Because here we have like a similar, because, like, in that question, in its decision tree, we don't draw, like, we don't indicate, or we don't show this obvious thing in our decision tree, because basically we don't make a decision, right? Like, in the decision tree, each node represents a choice, and also represents a recursive function call, basically, right? So, could you please clarify on that? Like, I guess, guys, spending like a 30 minutes for each problem may not be enough. Maybe we can make it like a 40 minutes or something, guys. Oh, C program lover. Yo, yo, welcome. Welcome in. How are you? Welcome in. How are you doing, C programmer lover? Today we study greedy lead code problems, and this is our current problem. And I guess I need to, like, we need to spend like around 40 minutes. So I already activated a few skills, and one of them is for making Cloud a teaching assistant, and the second one is for creating notes while we are studying actually. And I will share these notes on my website so that you can see them too. Let's see. First, read these parts. Good framing. You have goal, attempt, expectation, and hypothesis. So let me clarify directly. Node may not be choice. Pull them apart. Oh, I thought that in every, like, a dynamic programming vectoring question, like a recursive questions in general, these nodes represents the choice, because like in knapsack, in nqueens, in coin change problem, like for example in coin change problem, we had like a different coins, let's say $1, $2, $3, or $4, all right, and we literally represented them using, like, represented their choice, like our choices using those coins, like this one, all right, and we had something like remaining amount, all right, and this information was a state for us. So in our function, the recursive function, we were using this this information basically. But it says something new, something different. Pull them apart. A node, a state, one recursive call. I'm standing at index I. Here's what I have kept so far. An edge out of that node. Edge out of that node. A choice. Include or all right. It's kind of the same. It's kind of the same. So like it basically says these nodes represent states. So these edges representing choice, but they are kind of the same. So two options. All right. Recursive calls. The node isn't the choice. All right. We know it. We know it. Obvious. A dominance proof. Yes. So maybe guys, like, I can copy it. So because obvious means a dominance proof. Um, because sometimes in the solutions they don't mention about, like, why it is obvious. All right. Like they don't mention about the proof. So a dominance proof that delays sibling edges. All right. Exactly your two pointer string example at a match. The three edges, move I, move J, move both. Yes, all exist on paper, but you proved move both dominates. Yes, you snip the other two edges, no branching at that node. It collapses the single path. That collapse is the greedy. You read it right. All right. So now one prop before we go further, and it's the crack in your alternating versus not alternating. You called an element alternating as if it's a fixed property. Um, yeah, is it? So take, oh, old lazy lobster. Hello, welcome in. How are you doing? We are solving this wiggle subsequence problem, which is a greedy. I also sent you a message on Discord, I suppose, and followed your Twitch stream. I guess you're gonna stream like 2 hours each day, right, Lobster? I'm gonna check them. Um. So yeah, move both dominates. You snip the other two edges. No branching at that node. I do stream, but on YouTube. I see. I see. Then, but thanks for the all right. Then can you share the your YouTube account as well? No branching at that node. It collapses the single path. That collapse is yeah. So one prop before you. Mm, is it take 175? Is 5 alternating? actually, like I didn't say it's a fixed property. Like, of course I said that like a translate, I mean, like imagine we are in this state, all right? We should have the information about the previous state, and we should have something like prev, and in a new level we should compare our sign with the previous. So like, actually I had this mind, but apparently I didn't quite explain it, what I have in my mind. So you called an element alternating, yeah. So all right, but thanks for the follow. So let me follow you on YouTube. So now I'm gonna subscribe. Oh, you have 300 subscriptions. Wonderful. Oh wow. Live. Yeah. Oh, you are consistent. It seems that way. You've been uh you've been streaming for a long time, I suppose. And 400 videos. Wonderful. Like live videos. I see, I see. You are not new here. um all right. This seems good. All right. So, um thank you, but maybe I couldn't give or explain what I have in my mind. So of course we need a prev information, all right? Because when we are in a new level, we should have a previous, like we should have an information about previous choice and its sign basically. And if that sign is different, then we we can decide either we include or skip. So this is what I had in my mind actually. So to determine the change, we should have, like we should know the previous number, previous choices sign, mm, and based on that, we are gonna make other choices, basically. All right. All right. Let's press enter. Let's see if we have any live coders. Not yet. All right. So like it's gonna be like a 25 minutes, guys, but 30 minutes is not enough, guys. Like maybe we can even make it 50 or something. But not 3 hours for a single question, at least, all right? Yes, that's exactly. The carry down is the previous cap choices direction, guys. It's sign. Alternating only has meaning relative to that carried sign. Yes. Like this is what I meant, literally. Now collapse it. Yes, so this is what I've been looking for. The collapse. Like where should we collapse? All right, because let's say in this level, like we're gonna have, let's say, four stack, four new stack frames supposedly, and based on the sign, maybe we can eliminate some of the states. Actually, guys, like imagine we are in this state, all right? Imagine we skipped. So we should, like we are preserving the even previous number sign. So here in this state, the current number that is being processed is -2. We can either, all right. So we are like in this stack frame, we have two, like which is -2, and now we're gonna decide either include or skip, basically, all right. So this is where we make these two decisions, like in this stack frame. So now collapses. So now which one are we gonna collapse? Like, is there something obvious? I mean, for not alternating case, uh, we should we should we should skip it basically. So basically, instead of like a calling, making a new function call with -2, maybe we should process even next character, which is 2, the 3, I mean, here, and we should decide whether if we, whether we are going to include it or skip it. Now, collapse. You said flip in direction include, no regret, proven harmless. Yes. The same direction or equal, skip it. Yes. If every node has exactly one surviving edge after your dominance proof, what happens to the tree? Like, I guess it says something important. Let's see. Let's try to understand. So, like, there is something informative and helpful here. And the practical payoff, walking left to right, what's the one number you increment? Hmm. Oh, now I guess it tries to make us think about the result basic. Like we talk about the overall, right? Like include or exclude. But the thing is, how are you gonna count the real answer? I mean, I think it tries to think us I mean, make us think about the return values, all right, of these because we don't have like a global array or something where we store our answer. Like we should, like what I mean is that our functions are not void basically. Can you explain how uh the works? I didn't understand. um, I didn't understand. So like we have -2 and +3 here, and these are at different levels, and and their signs alternating. So we decide this alternating case based on like a previous information that we have in our state basically because our function has that prev sign or information. So it's been 30 minutes, guys, and we haven't finished the problem yet, but no worries. Um, we can start another one, right? There is nothing stopping us, but before starting, guys, maybe we can, I don't know. Oh, let's see. Oh, the room, the room code. Like, this is a room code. You can like this is a website where you can join and you basically share your code and if you need to send some images or share some diagrams, graphs, you can share it here too. It is live. um, we can study on a lead code problem together. um, yeah, actually here I'm using WebSockets and some open source libraries for synchronization. Um, you can join actually. You can join and test it. I've used open source libraries in this website for coding section and synchronization parts. And actually, I can post a question too. For example, for this question, I can ask, what is the dominant factor here so that we can collapse our options. Post a question, and if you join here, you can answer and you can get some points. So I I should be able to change it, but I guess since it is live, yes, let's stop it and then let's make it 50, guys. I think we're gonna go 50 today. Let's start it. All right. Um, also maybe project Twitch. Can you please list the open source libraries that we have used in this arena? One of my friend is asking, um, so that we can share our components. All right. I'm not big up on Litco. All right. All right. So, like, now I asked which components we have used here, and I'm gonna share its answer with you in a second. I'm not big of Litco too, but I really want to understand. Like, I mean, I'm pushing myself. So Socket.io. So um, let me let me share. Can I share? So there's a limit for that. Basically, I used Socket.io. All right, and the remainings are, you know, not that fancy. React and Monaco editor, like for coding, there's open source library for code editing, which is Monaco editor by Microsoft. Yeah, the remainings are some visual. All right. So now we have 49 minutes, guys. Let's see. Um, all right. If every node has exactly one surviving edge after your dominance proof, what happens to the tree? Mm, if every node has exactly one surviving edge, what does it mean? One surviving edge. Actually, yeah. So I think it tries to think, like, it makes us think about the return values. How should we design the return values, basically, all right? Because let's imagine a recursive caller, right? This is a stack frame, and we have, let's say our prev sign is equal to minus, obviously, right? We have this information, and we know the which item, which integer we are processing currently. So apparently we need some sort of index. Let's say we have minus 1, 2, and 3, all right? So previous index, the previous sign is minus here, right? And index is now is 1, apparently, right? So in this stack frame, um, in this stack frame, um, we're gonna, like, we need to compare, obviously, right? The current sign and prev sign. But what about the return value? We should return. Maybe like we may have, like, we can have a base case. All right, base case can be about the index. If it reaches length, basically, right? We can return that counter. We can return that counter. But how should all right? So it is like when they match, it's a bad case for us. But if we have alternating ones, uh, then we can increase that counter. But where are we gonna store it? Are we gonna store it in our parameter? Maybe like a maybe new parameter, or but it is return. So let's think about the function call two. If they are not equal, we increase the counter, and now we have two options, right? Include and exclude. But um, one of so when alternating case, like, we said that maybe, like, including it has some superiority over uh over the other option. Um, but since we are now doing the brute force recursion, All right, we should call basically include, and we should also call for exclude and explore these. Like we don't, like this is now brute force, and we don't know which one uh, will be better. All right, this is brute force. But now, how about the returning values? What are we gonna do? What are we gonna do with them? Maybe we should maybe we should return the maximum. How about that, guys? Maximum of these choices. Well, what do you say? And when we hit the base case, we can return the counter. Does it does it look good to you guys? Does it look good? Hmm. Let's us. Um, a practical payoff. Walking left to right. What is the one number you increment? Walking left to right. It says left to right or top to bottom. Actually, left to right. It means you know processing, and in our tree we processing mean taking and going down. Uh, so all right, now we have thought about some counter. All right, now let me explain this idea to AI and let's see how it will answer that. So I guess you are trying to make us think about the return value of our recursive function, all right? And the definition, like a state arguments for our function is, previous sign, an index, and maybe a counter. Like I'm not sure. Like we are not sure yet. We are not sure about it yet. But the recursive function we have in our mind is that like it may have a base case where the index is equal to length of the array, and we return that counter maybe, right? Um, and if we hit non-alternating case, um, if we hit non-alternating case, um, if we hit non-alternating case, like there should be one obvious option, right? Um, we literally skip it basically. So we can call like we can call our recursive function recursive function using like with index plus one, right? This is one obvious choice. And for alternating case, we can increase our counter, right? And then discover our options, including and excluding. But now, like we feel, like I feel that like we need to think about the return value. But let's say we return the maximum of these two returning return values. But in that case, like we use like a counter in our argument, and we also have like some returning value. So they kind of contradict. All right. So I feel like I need to find a better way to store this information, and that place could be yes. So that place could be, let's say, one plus func include, and for exclude, one plus func exclude. All right. So forget about this counter being an argument for us, because the information we need from our parent is the previous numbers sign. For this counter, we can literally use like a one plus func, and we can store it in a variable for enough, and for our exclude choice, we can store it in another value variable, and we can return the maximum of them. And also And also I realized that, guys, maybe for exclude we don't we shouldn't add plus one. And C program lover says, why don't we look at the solution? If we look at the solution, we can understand immediately, because seeing the solution, like while I see, like while I'm looking at the solution, I say, that is easy, that is easy. But coming up with that solution is kind of hard, and to be able to capture the underlying, the fundamental logic, like I should struggle basically. As I struggle more, I learn more basically. Like we have, we even have the animation, all right, that we have created on Blender. This is the solution, this is the solutions animation. Like this is the end result, this is the end result, all right. um so I can literally understand it. So like having a graph, and by focusing on the increasing sides only, we can count those moments and return. So even using a single for loop, um, we solved it basically. But now the thing I'm trying is to understand our available options, choices, and which of those we can collapse, and which of those we can create a proof, like a dominance proof. Who invented algorithms? Yeah, yeah. Like it is like I don't know, like I didn't even study this much for college entrance exam. Let me be honest with you, all right? Of course, I've studied a lot, all right? But like this is kind of my second college entrance exam, all right? Like there are lots of lead code problems, lots of topics, lots of subtopics. Like let's look at it. For example, I created 7 subtypes of greedy, all right? Like I am familiar with this family, like a running state. Like I can easily solve this type of questions, and maybe this one. But for the remaining parts, like they have some unique approaches, unique styles. So I'm trying to get familiar with them. um Today we are solving this part, but even each subtype has different techniques basically. And also we created another, you know we made another analyze, and the technique, for example, is called invariant, exchange, and lower bound. And also I figured that even even knowing these techniques does not help you, all right? Because when you see a different question for the first time, you don't know what to do. You don't know which technique you're gonna use. You are supposed to use, which subtype that greedy problem belongs to. Even you don't know if it is a greedy problem or a dynamic programming problem. All right, or even maybe a sliding window technique. All right. So I figured that to fix this issue, I should see my options. I should determine my options, available options. I should see which one of them, or which one of them is like has some superiority over others, and which ones I can collapse, which ones are abuse ones basically. And I should create the proof, dominance proof, so that I can eliminate those options. This is actually specific for greedy. But this also, like this approach also helps for dynamic programming questions. All right. Let's see. Um, all right. So I was saying, I think, all right. So like now, also maybe for excluding case, maybe we shouldn't add plus. I mean plus one. We shouldn't add one. Because for including, we included um current item, and we increased the length of our subsequence basically. But if we exclude it, we don't have it basically, and the length of our subsequence doesn't change. So basically, yeah, we most probably we shouldn't add one here. So it's been 15 minutes, guys. We should go faster. Faster. Come on, guys. We should go faster. Oh my gosh. Like, it's been like a 30 minutes plus 15, 45 minutes. And in 5 minutes, it's gonna be 15 minutes. Like, each question requires at least 1 hour, guys, for me. Big unlock, and you code it yourself. The count is not an argument carried down, it's built up through a return value, like these guys. No plus one, you're right. Excluding doesn't grow the subsequence. Wonderful, guys. Return, yeah. So this post order combine up channel, as we call it, guys. The sibling of the carry down we just named. You use both. Sign goes down, length comes up. Exactly. So now tighten one thing. You keep saying you carry the previous sign, but to even know if include mm, you, I guess, guys, I see what it mean. Lit code problem or no? This is a lit code problem we are solving. This is a lit code problem. Wiggle subsequence. This is a lit code problem. Um, I see. I get what it means. I guess now it pushes us to think about when, like, how we manipulate, how we use these previous sign information, basically. All right. Um. So for the part where we include, we should update previous sign because we are literally using the current item. So we should update it, right? For exclude, we should share um, previous sign that we have in the stack frame. All right. So yeah. So I guess now you are pushing us to think about how we manipulate the sign, like a sign of previous sign, basically. So for including case, we should update it with the sign of the current item, which I mean item at index. I mean item at index. Yes, this we have this parameter, all right? But for the exclude case, we should just pass that prev sign information we have in our current state frame, since we don't um, include, so that the previous sign is basically the last item we had. I guess yes. Um, I mean that what's the number? Oh, all right, all right. So the pro number pro it is 376. 376. Wiggle subsequence. Wiggle subsequence. I think I can share the link. Yeah, so this is our problem. Why it is running? All right. Let's see what trace it. All right. I think we had done something wrong, guys, because when I have done something right, it says correct, wonderful. But let's see. I think we've done a mistake, and I don't see where. Let's see. Subsequence so far kept. So prev sign. Hmm. Actually, guys, the decision tree that we like. Mm, decision tree that I built is built upon the sign array, right? Array of signs, not the array of inputs, basically. But it doesn't matter actually. No, it matters. It matters. The differences, like our decision tree is built upon the differences array, basically. So it now tries, like, the array it uses is the original array. So prev sign is positive. Now you are at nums I5. So to the side 117. Which example is this? To the side is including 5 a legal flip. You compute a difference and check its sign against previous. Write that diff for me. What number goes there? A minus, and is it a sign or a value? Actually, my like our decision tree is built upon the differences array, not the input array, basically. But I guess even that case, actually no. Like if we build our decision tree upon based upon the differences array, hmm, actually I need to think about the input array, right? Because if I do that, if I use differences array, then maybe it may be hard which one, like which one the first, like what is the first element and what is the previous element, what is the current element, because differences can be positive in two ways or in a single way. I mean, like it is not about signs. All right. I kept confusing. I kept mixing them up. We are not talking about the signs. We are talking about the differences. We need two inputs basically. Um, so for differences, numbers like maybe the prev number is negative and the current one is negative and even smaller than that, or the first one is positive and then second one is negative. No, in that case the difference would be, yeah, if first one is previous is positive and the current is negative and then difference is positive. So maybe I should think about this more. I'm going to try it. Yeah, do it. um like I thought using the differences array will guide us, but I think our decision tree should be built upon um the original input array. Yeah. So the question it asked, let's say we have a subsequence this one, and here the prev sign and prev number is 17. The prev sign is positive. Now we are at we are in this stack frame. Hmm. I think sharing the sign information is not enough. We also we only need to share the previous number, not previous sign. I guess we don't need to share the previous sign. We should we have to share the previous included number. But also question asks, mm, yeah, we need to share the previous picked number. And if the sign is changing, I mean the difference, um, if the difference is positive, we include. So we don't need sign information. We need the previous picked number, right? I guess this is correct, guys. Yes, you need the previous picked number. So the current number minus previous. Yes, so this is the difference. This is how we calculate the difference. So that was the gap. Carry the value, not the bare sign. Yes. But don't throw the sign away entirely. Used to too far. So if the previous value is 17 and the current is 5, the difference is minus 12. So is including 5 legal? Uh, no, I guess. It depends on how you arrived at 17. If you went up into 17, then goes down, then down to 5 is a real wiggle. If you come down, come down into 17 and down again, so the difference sign tells you the new direction, but legality is new sign versus what second piece does the parent still owe you? What second piece? Mm, actually, like I didn't think about that part, and I should have. It depends on how you arrived at 17. Actually, actually, I thought that the only thing we compare is the, like understanding the question correct is quite important. So I thought, let's say we have number 1 and minus 2, right? I focused on our option, which is not wrong, by the way, but let's say 5. And here I mixed the sign with the difference. We should focus on the difference. Is a bigger sequence because the differences alternate. Oh my gosh, not the numbers, differences. um so they say here the difference is minus 3, and here it is minus 7. So this is not alternating. So when we find not alternating difference, we have two options. I mean, one option actually, we should skip it, right? We should skip this. Or we can start, yes, this is the second option. We can start from here. Yes, we have two options. Actually, now that I thought about the question again, all right, since it is about the sign of the differences, all right, let's say we are at a level in our decision tree where the difference is minus 7, and let's suppose previous difference was my previous difference is minus 3. Like, we have two options actually. We can start fresh from this character, this item, all right, or we can skip the current choice, right? Mm, so let's think about the alternating case. Imagine previous difference is minus 7 and the current difference is 8. Since they are alternating, we have one obvious choice which has some dominance over. It is um selecting that item. Mm, yeah, so we should select that item because skipping does not make our subsequence length any better. So I guess this is no regret choice, right? Let's see, guys. Press enter. Like, I realized that I focus on the signs, changing signs, but it's not about signs, it's about differences. So when it is about differences, we need to have, like, we need to have the information of the previous picked item's value, all right, as well as the sign changing information. I mean the difference basically. Yeah. So sign of the difference basically. Like these are items, these are differences. All right. We need both of them. We need the value of item because we're going to calculate the current difference, and we're going to compare the current difference with the previous difference. We don't know where that differences may be. I mean, the previous might be. I mean, maybe the last, like a consecutive previous one, or um, even beyond that, before that. But it doesn't matter. Yeah, it doesn't. Yeah, it doesn't matter because it is not a subarray. It is subsequence. That's the greedy. All right. I think we have found it. And you proved it the right way by comparing include versus skip and showing skip cannot win. All right, guys. I thought that like finding this greedy and kind of hard, but it is not hard. Um, because it is kind of obvious for us. I mean, we can literally say this is the best option, this is the best choice, but you need to determine your choices correctly. All right, because as a human we can literally see this is the better, and what we need to do is maybe proving, or maybe we don't even prove that to come up with the correct solution. um, it is mathematician's job. We like our job in grid problems determining our options correctly, and then finding the best one and create the solution basically, right? So best one here is no regret one is including. So we include for non-alternating part. So now let's think about non-alternating. So we literally skip it. There is no option. We skip this. Oh, skip or start fresh. Yeah, yeah. We we have these options. Yeah, this is also important. But none of them has some dominance over the another one, right? Here. But here, in alternating case, including is the best. So we optimize basically this part. We apply some greedy here. All right, all right. That's the greedy. Alternating differences then include adds one to the length now. The only worry with a greedy always include is the future. Could grabbing it now block a better choice later? Yeah, like we actually, yeah, like this question is also important, guys, because we need to prove it that it will never harm us. But after seeing this one, I started thinking, maybe it can finish the proof on that axis after you include uh, positive 8. The next difference, yes, the next diff we are hunting for must be negative. Mhm. If instead you skipped plus 8, what sign would you be hunting for next? And is that position any better? Oh my gosh. So the way it put like this way, it is, so we need to prove that this doesn't, this doesn't, this won't harm us, this choice. The heart of no regret include both adds one and leaves you no worse off for the future. Hmm. So now we need to prove that, but if you include a number that gives us positive difference, then the next character, next item should give us negative. but it may not. So when it doesn't, I don't know, I don't know. Like like I am kinda empty here, alright? I feel a little bit lost over here. Because if we picked the current item that gives us a positive um, difference, but maybe the next character will give us another positive difference. So this will cause us not picking the next character. So like how can we prove it? Like um I don't see you need to guide us. Like now the thing I'm trying to understand is that like I've talked about two different cases here, like a alternating one, and I said that this is the best option, but now it says that is it for non-alternating case I said um we should skip it or start fresh. Are these two different choices that we need to care about here? I mean, we definitely should skip it because it doesn't provide us anything. But skipping means we should continue with the continue using our, you know, let's say running sum. I like this term. Our previous subsequence length basically. Like, should we forget about that, or should we, forget about and start fresh, or should we only skip and keep adding based on the running sum? But most probably, like I need some clearance here, guys. I need some clearance because skipping starting fresh for non-alternating case, and for alternating case, I said like this is literally no regret, but it says is it? It questions this idea, and I have no answer for that. Mm, Actually, as Lazy Skimmer once said, we should observe, we should examine different cases. But here, by looking at this decision tree, does not give me any clue. Like it gave me clue about, you know, about this non-alternating and alternating case. So we literally like about the cases, about the situations I may have. Now, based on those different cases, how we should behave, how should we like, where should we apply collapsing? Basically, like this is some another phase. This is the next phase. This was the first phase. The second phase is now these are your cases. What should you do? How should you collapse? Basically, like, this is phase two. Mm, yeah, like maybe I should just like, all right. So imagine like a all right. Let's say this is difference, and this is difference. All right. So imagine we are in this stack frame, all right, where the difference is -3, and the prev is, let's say, 5. All right, it doesn't matter. Actually, it does matter. Prev is 5, and now we are processing a number x. All right. So we should get the difference basically, which is x minus 5, and we should look at its sign and the prev sign. All right, this is prev sign. We should look at the prev sign, and like these are informations we need. Now based on these, we should um decide basically, decide to include or exclude. If we include, like we're gonna call like this one. If we exclude an index +1, all right, this is the exclude. And also of course we are going to update the previous one. um like include, exclude. Like here, I don't observe the different cases. I mean, I don't stress test different cases. Like I write the condition basically. I mean, if the if the sign of difference is different, we should include. If it is not, we should exclude. So, but now AI said that, let's say you included, all right. Actually, maybe its focus is here. Let's say you include something, but that include, I mean, include, uh, like, will it or will not harm you? I don't know, man. So don't prove it in the abstract. Run your own worry as a concrete race. Here's exactly your fear. Two positives in a row. Like these are our diffs. Say the last included diff before these was negative, so you're hunting a positive. Trace both branches. You can't. Branch A, include the first, yes. Mm-hmm. Alright, alright. So let me take a screenshot and see. Um, so these are our two branches, but if the previous one is negative, then we should definitely include it. I mean, we don't branch there. We have a if statement. All right, maybe I can ask this later. So branch A, include the first. Yeah, so we are including length plus one. Now hunting, hunting for the negative one. Next is plus 9. So can you take it? Next is minus 4. Take it. So total taken from here. So branch B, we skip positive 8, still hunting for positive because the previous difference is, negative. Hmm. So we slightly, like almost same, we almost have same thing here. Um. So my question is that I thought for alternating difference, we branch only this. But here it says include or skip it. And also for including case, I mean, we increase our length, the counter, and now we literally here update prev and we make prev to, plus 8. But this is what it means. Now hiding this one. Like we don't say this is what we are hunting. We say this is now prev for the next stack frame. So make your calculations based on that. So like even translating these two words is kind of crucial. So thank you, but there are some parts I didn't understand. All right. So the thing is that um let's say our previous previous difference sign is negative. All right. And if like now in the current stack frame, we're gonna calculate the difference using the current item, right? Current item. Amazing. Now, if the difference is, I mean, positive, all right, there is only one option, the one branch. There should be one branch. We should include it. I thought you were asking including that character, like would it harm us or will it harm us in the long run or not? uh, it won't. But here you like you show two branches, like including and skipping. Like I know, like this include or skipping, um, like I don't understand because I thought we may have like a, if we let's say we have a non-alternating difference case, all right. I thought that we can skip, all right, current item, or we can start fresh with this um item. All right. Since it's a subsequence, we can start fresh. And I thought like we have two different choices here. And but for alternating case, I thought including it is only choice for us. So now the way you put is kind of different than what I have in my mind. So it's not clear to me. And also like including and skipping seems valid at first sight, but do we like like are we doing these are we making these choices in each iteration, no matter what? I mean, no matter what we have as a previous, no matter what we have what we have in current item and its difference, because I know some recursive functions where like we literally have some if else statements, all right? And based on that we make some different choices, all right? But now here I don't see those if else statements, and this troubles me. Can you please clarify on that? And also, all right, so now I'm gonna ask the next question, but first let me paste, because sometimes after long uh, dictation it may fail. So now um what I understand, why I don't understand is I mean, actually most probably you are trying to make me focus on the part where the like focus on the dominance proof basically, all right? Most probably you are trying to show me this, and also this is actually the fundamental part, like the crucial part for this question, all right? But before coming to that part, I didn't understand our branching. How do we use if statements versus real choices, all right? Like i I should be able to draw my decision tree, all right, but I can't right now. And but I totally get the part that you are, I mean, your reasoning behind showing this, because this is quite important, because like you're asking me that like including the current item with the positive, you know difference, like will it harm us or will it not? How can we prove that? Maybe you can start with proving this one. um but also I need some clearance about these, I mean, if statement choices, all right? Let's see, guys, let's see. Like I thought we can solve this problem in 30 minutes after 10 minutes of thinking and 20 minutes of understanding, but it is apparently it is not enough. And I don't want to skip any question without understanding, all right? um and we have we have lots of questions here, and if we spend 2 hours for each of them, right? We have four here, 8 and 12, so 12 hours of work here. So it means this is gonna be long stream, guys. 12 hours. mm, like I mean 12 questions, and we need to spend 1 hour for each. I remember for some problems we have spent 3 hours, guys. All right. So great question. This is the crux of the whole method. So let me cl- clear it up. You are mixing two layers. Yes. Layer zero, the honest burst. Yes, yes, yes. These are first layer. So I decided for most of the grid problems, if you know, if you start with layer zero with creating decision tree and brute force, um, it will guide us. So at every element, there are always two edges, include or skip. No exceptions. No if deciding which edge exists, alternating or not. Both branches are drawn. This is exactly your knapsack 01 shape. Every item, take it or leave it. Take or leave, alright? The tree is fully bush, alright. So the only if that lives in layer 0 is a legality guard inside the include branch. Inside the include branch. Um, all right. So can I even include this? Can I even include this? For us to be able to include this, we need to check the difference and check the previous difference and decide on that. Because like we have a rule we need to apply. For skipping, there is no if. All right. For skipping, we don't have a rule. But actually, guys, for skipping, we don't have any condition basically. We just do it without any rule or guard or if statement basically. All right. Because I thought that like we have a legality guard for inserting, including. How about excluding? Maybe we have another rule that will guide us or that will lean us to that choice, but we don't. We just explore. This is why it is called brute force. But even if it is brute force, when the like actually this is legality guard, guys. Like this doesn't um make a choice better than other. It is just the if statement. All right. Can I even include this? Um. So is nums I a valid wiggle step given my last sign? If it is not legal, if it is not a legal flip, the include branch is simply not allowed. That's not pruning. That's the rules of the game. Oh my gosh, guys. I guess I'm mixing these. I mean, pruning versus rules of the game. Yes, yes, yes. This is my weakness, guys. This is my weakness. Like I see it. I see it. Rules of the game versus pruning. I thought they are same. They are the same, but it seems they are not. Like this was layer zero, like a creating brute force decision tree. The layer one is the greedy. For that part, we need to collapse some of our options. But here guys, the important part is like it literally said that like we have two options. Include. Either we include or exclude. So greedy, like for me at the like for I think that like greedy should tell us. I mean, include has dominance rules, dominance priority. I mean dominance. So forget about excluding, pick only including. But here, this cannot be the case, right? I mean, or can it? Can it be? Let's see. Let's see. Because in the previous greedy problems that we have solved, we had some, let's say, different options in a level, and we figured like we proved that selecting these two um you know has not any superiority or dominance. So we don't explore those choices. and even this one, and the greedy one was telling us this is the best option. But here we have only two options. We have our rule of our problem. Maybe like it is like this question told me about pruning versus game. I mean rule of the game versus rule of the game, because I thought they are same. They are the same. So all right. So I'm gonna read your message, but now I need you to create a note and publish it on my website, because and also check the moment of our stream and add a timestamp there. And um, this problem taught me the difference, or made me see the difference between pruning, all right, and the rules of the game, because I thought they are the same. And also, you can create another time step. So another thing that it taught me is, in another greedy problems, like we had, let's assume we have, four options at a level, right? I thought like a greedy has some dominance over other options, and that's why we picked that option. Like it is kind of true, it is kind of correct, but like in this problem, like it is kind of different, because like we have like our options are determined and fixed. All right, we either include, we're gonna either include or exclude, but we have some rules. All right, for including case. Like the fun part in this question was thinking about um, the state information we need. We need previous differences sign, and also we need previous choice itself. All right, we need these to decide whether whether we can include or not. It is not about we are gonna if we are gonna include or exclude. We're gonna do these two choices. We're gonna make these two choices, I suppose. So could you please create these and publish it, all right, in my website, and then I'm gonna read the message you just sent us. So starting from today's stream, guys, we're gonna have some notes, all right, and I will share them with you on my website, so that you can see. So let's see. This was layer 0, and the layer 1 is the greedy. The if statements you are looking for are not the brute force, they are the output of a dominance proof. Output of a dominance proof. Output, not input. Alright. When I prove in the alternating case include bit skip, I've earned the right to delete the skip edge. That deletion written in code is your if. I don't understand what do you mean. So your intuition alternating only one choice include is the conclusion, yeah. My branch A include versus branch B skip trace is the premise. So I drew both branches on purpose in layer 0. I mean on purpose in layer 0. Like, should I connect with the previous part or the next one? Because that's the only place I can prove skip never wins. Alright, alright. I guess, guys, we're gonna prove excluding is no better. I can prove skip never wins. Once proven, skip vanishes, and you are left with your one choice greedy. Oh my gosh. So we have these two options. Like, we literally have these two options. And we're gonna collapse one of them, which is exclude. Um so That's why you don't see the ifs. What do you mean by if, man? We are still earning them. So the sequence is Bishri always to prove skip loses, collapse to if legal Philip take it. The trace is step two. Want to finish? Alright, so maybe guys we can create a visual. Alright, after this, you are live, publishing now. Alright, alright. So you can reach the node here. Alright, let's see what we have here. Oh, we don't have. Or should I copy all of? Let's see. Let's copy this part and see. Actually, I don't see it. One blocker on the website push the deploy step reports said so. The nodes are in a local DB was regenerated, but nothing was until this configured. Hmm, I don't see in that list the discover. You tell me, and I'll set. Actually, I've done this yesterday, but and it was working. I guess you run it yourself in the station. Hmm. All right, I will handle this during break, guys. All right. So now, can you please generate some PNGs? Um, I guess we were using some open source library or something, right? What was it? It was really, creating good images. What was it? I'm not talking about three blue, one uh, brown, I think. The other thing for creating PNGs. What was it? Like, I want to see the include and exclude choice and why we like and if statements basically. All right, it's gonna be almost 2 hours, guys. But like I've learned a lot. I've learned a lot. Like pruning, rules, and rules of the game. Um, they are different. These are our options. Like because here, for example, I thought our options like a start and skip and start fresh based on the non-alternating case. I thought these are our two options, and for alternating case this is our option, but it is not correct. Our options are include or exclude. The remaining stuff is kind of rules of the game, rules of our game. And also it is not about pruning as well. So we've discovered a lot. We discovered a lot. um yeah, so yes, I was talking about that. hmm it creates amazing. um and also it says something about you. I won't keep poking at your server. Two ways for your pick. mm, hmm, I think I can run this here. Can you open them for me, for us? And also, all right, we have our image. All right, let me paste it over here. Like these are images. So we have index and prev, honest brute force, yes. Include or skip. So by including, we earn one, right? Because now the our subsequence length is one greater. We are moving, and we are making prev. But we don't have the previous differences sign. This is knapsack, yes, shape. Every item, take or leave, always push it. So return value carries the length up. Alright, so rules of the game versus pruning. Two kinds of if that looks identical in code. Oh, alright. One is given, one is earned. A dominance. Oh my gosh. Don't confuse them. Rules of the game. We have like a legality guard lives inside the include the include branch. Can I even include the current item? So all right. Pruning, you must earn it with a dominance proof. Skip can never beat include here. So prove skip is smaller than less than include. Delete that skip edge. All right. Same shape on the page, opposite origin given by the problem versus earned by you. All right. Like my another question is that why don't we have the previous sign here? Like we have the previous number we used. Can we extract that sign from this one? Let's see. Let's see. Dominance proof. The collapse bush the single grid path. One surviving edge per node. One surviving edge. So dominance proof. Yeah. Like we literally turn this decision tree into this one. Like a we are skipping. If legal flip, if so, this is the rule of the game. This is rule of the game. All right. So all right. So here, why don't we have previous differences sign? For example, here we have. All right. Anyway, um. Also, guys, for a second, I just want to take this to here. All right. In case I don't expose anything. Um. Can you please continue? So after this question, we have merge triplets, but I hate triplets, so we're gonna continue with Dota 2 Senate, and like this question, I don't know, like this is different, guys. This is different, but we're gonna focus on that part, and I don't know, maybe it is gonna take another 2 hours. Let's see, but I will try making it under 2 hours. Um, like I think we can take a break, and in this break, I'm gonna handle our website where I plan to share the notes. All right. And I'm gonna have my lunch. So, how about 30 minutes break, guys? Because maybe even 35. I need to handle these both. Mm, or let's wait a minute. Maybe we can handle the website, because in the website I plan to, you know, share the notes for our every stream, like which parts we had struggled with, the important parts. And also, while when I share this stream on YouTube, I'm gonna have timestamps. All right, I think it says it is live. Let's see if it is. um yes, it is live. All right, guys, it is wonderful. So, putting versus the rules of the game. Yeah, yeah, yeah. So this is wonderful. And grid isn't always pick the dominant option. Sometimes the options are fixed. Old mental model, a greedy level has, um, say, four options. One of them dominates the others. So you pick, yeah, yeah. Here, options are fixed in and binary. Like, even recognizing this is quite important, like quite crucial, guys. Here, the options are fixed and binary. At every element, like you can also check the notes here, guys. Um, at every element, you either include or exclude. You're always going to face those same two choices. There is no menu of for to rank. So the interesting work is not which option dominates. Oh, the interesting work was the state. It's like it mimics, like it copies what I just, but to decide whether the include branch is even legal. Mm. I had to figure out what information. Yeah. So the previous picked value. So without both, you can't tell a legal wiggle from an illegal one. So now I don't understand which part is like what makes this question greedy basically. Maybe I can ask this. All right. So mm, all right. Create a memory about it. So I think I can open this. Actually, wait a second here. All right. This is gonna be fun, guys. This is gonna be fun. We have some valuable information, and our next question will be this one. And I really wanna, maybe, guys. So if we have 12 questions, and if we dedicate 2 hours for each, so maybe from now on I should dedicate 2 hours. All right, but that should be at most. That should be our limit. All right, and like obviously today we cannot do 24 hours stream, but tomorrow we're gonna have 18 hours long stream. And today our focus should be completing as many as possible here, because tomorrow I want to do some overall review and restudy and create some summary, and also create these notes. All right, uh, in the website. So I will try solving all of them basically, because we literally completed almost all of them. All right, all right. Yeah, yeah. So tomorrow, at minimum, our goal should be maybe 50. Is it doable, guys? But if we spend, let's say, half hour for each problem, then it will mean 25 hours. So, so for some problems, we should spend only 5 minutes or all right. So we should determine the minimum, like a lower bound and upper bound, basic for each problem. If we wanna complete, let's say, six of them in 18 hours, if you subtract the the breaks, let's say we have 15 hours long, you know, focus time. All right, I'm gonna do this calculation later. So index memory. Um, all right. So now the point, like the yeah, the place where I wonder is like, can you wrap up and can you list all the stuff we need to know? Because I will have my lunch now, and I wanna complete this problem. And I figured in this question our options are determined. And also I wonder, like we wonder that what makes this question a greedy. Like in this question we don't have, let's say, 10 different choices, and we don't collapse nine of them and find the decide the best option. But where exactly we do like where exactly are we doing the dominance proof, and what makes this question greedy? All right. And also list everything important related to this problem, because like I want to complete this. All right. It's gonna be 2 hours, almost 2 hours. So wrap up. So guys, um we're gonna wrap up this question. This is enough. A running sign invariant. So invariant is basically, guys, maybe we can translate this into like an information that we need to define our state, right? Can't each direction change in one pass? I should press enter. The one liner for this problem is, can't each direction change in one pass? A running sign invariant. Invariant, stay ahead. I don't understand anything with these. Stay ahead. Let's see, let's see. Um, I can, I suppose, get this one here, and I want it to be in the middle. Wrapping up, first, your two real questions, then the full checklist. So, what makes this one greedy? And where is dominance proof? Yes, you are right that there is no menu of 10, because like we had a greedy problem where we literally have like a for loop, and in that for loop we literally were discovering or processing each item in each level. So you're right that there is no menu of 10. The greedy is hiding somewhere narrower. The brute force gives you two edges at every element, include or skip. Always, this is the layer zero. And the dominance proof is exactly there. Include versus skip. So claim, whenever including is a legal, like look at the definition, look at how it put into words, guys. Whenever including is a legal. So as we see this, we should immediately think about the if statement, and that if statement is actually, guys, rules of the game, not even pruning. See ya, drop by real quick, currently in transit to part. Oh, all right, thank you for dropping by, Americano. Like, it is good to see you. Thank you for dropping by. It is good to see you, man. It is good to see you. How are you doing? To part time. Oh, you are working. Nice, nice. Tomorrow we're gonna have 18 hours long stream. Are you gonna be able to uh join us? So Americano redeemed rosemary oil. So let's finish. Thank you, Americano. Like, it smells good. Um, Tomorrow, like, are you gonna be able to attend, like, a join Americano? 18 hours long stream ahead. Yes, at tomorrow. Yeah, yeah. We're gonna try solving all of the questions we have here in Grid, or some of them, part of them, but mostly all of them. Most probably all of them. Hopefully. The dominance proof is exactly there. Include versus skip. Whenever including is a legal flip, uh, so this is the rule of the game. Include greater than skip. Take it now can never cost you later. I guess I I told this, right? I told you guys. I mean, this is no regret, but after AI asked the question, then I thought, how am I supposed to prove it? Because I can't. Train already that I see. All right. Take care. I'll try to be more active next week, maybe, but current. All right. No worries. No worries. Take care. Um, take care, my man. Um, so taking it now can never cost you later. Prove that. Thanks. Bye bye. um, prove that. How am I supposed to prove that, guys? And you delete the skip edge. Oh my gosh, am I gonna be redeem another rosemary oil sniff? So, like this is guys, this smells good. Thank you, thanks Americana to making me my brain cells function better. Like this really helps focusing. All right. Thank you, Americana. um, no regret core. The proof you left open. Um, Your fear was two positives in a row. Resolve it with an exchange argument. Among consecutive same sign diffs, any optimal wiggle uses at most one of them. If it used a later same sign diff swap, or oh my gosh, I'm hungry, guys. I should have my lunch. That swap and you are no worse is the whole greedy. Include adds one now and leaves the future no worse. To complete checklist, state your carry. State you carry. Previous value to compute and prev sign. Yes, so although we don't have, like, although it didn't show here, we have that information as an argument. To compute, yes, to and prev sign the direction of the last step to test the flip. So on the direction array, difference array, um, these fuse into one thing. The sign of the last difference. The collapse include carries length up 1 plus only on include. Sign carries down. Final algorithm, like, all right, we have prev sign. Like, actually understand this code is not easy. Is easy, but the logic part. So I don't care about the code, guys. To be honest, I don't care about the code. Like, writing a for loop, everyone knows it, right? The meta lessons for today: rules are not pruning legality. So fixed options, the puzzle is the state. When the choices are always include exclude, the real work is discovering the carried state that gets the legal one. Running state counter family, same sweep once carry. All right. Mm-hmm. All right. Actually, before taking a break, could you please show the proof, like a dominance proof once more, in more detail, or like, are we supposed to prove it? Because like seeing it kind of, like, maybe easy, like seeing it easy, right? Uh, but maybe for greedy problems, like, since I'm not a mathematician, all right, I don't need to prove that, but say this is the greedy option and this is a no regret option, and just literally type the code, all right? Because in this problem, you know, determining our options kind of enlightened me, because like in the previous the greedy problems, I've seen different kind of greedy problems where our options were different basically. But here we have something different. But again, still I should like show the dominance proof, all right? Because in our chat you asked a question about like uh, on a on a case where the previous um, difference is negative and the current difference is positive, and the next is one positive too. You ask us a question, but even answering like proving, I mean, proving that including a positive difference is um, you know won't harm us. Mm, could you please show guide us? Like, should I prove that, or should I mean, at least be able to see that? Because in some questions, for example, container with most water or trap water question, like mm, there in those questions, like I could seeing the no regret option, the dominance is was easy because I should literally pick the the next smaller or next higher bar basic, like something like that. But there the seeing the greedy was easy. Here greedy is like determining the dominance proof is not easy, but the choices like determining choices is easy. So I guess in each greedy problem they may have different aspect of greedy. So could you please clarify on that? And like in during the interviews, um, what what is expected of me? Proving or seeing the greedy option right away, and coming up with the code basically, all right? Like determining the options and collapsing those options and saying this is greedy, like this should be uh, the greedy choice. So well, can you guide us a little bit? All right, let's see guys. So I should also update the current topic. Press enter, and also current topic now will be, guys, actually currently it is this. So let's be honest with our topic, create problem. All right. Let's see, like I really wonder guys, like, and I really like, wanna solve the next question total because, and then let's see what we have. Eliminate max monsters, removing stars from a string. Oh my god, like even the names of these questions, we're gonna have so much fun, guys. Like at least watching these streams is easy. Like I open sometimes my streams, and I lean back and drink some tea or something, eating some food, and see the sacrifice that I have made, and how hard I'm trying, how hard I try to solve and understand. Like watching is quite fun, but right now, like, it's kind of hard. So let's see. So these are exactly the right questions to ask before you walk away. Let me give you the detailed proof, then the interview reality answer, then the code, the dominance proof in full. Um, you've been scanning. Your last cap direction is down. Previous sign, yes, yes. So you are hunting for an up. Current diff is up basically. The very next diff is positive again. You fear if I grab 8 positive 8, the 9 is wasted. Yes, so raise the two strategies from this exact point and take 8 now or skip. Guys, we already discover, I mean, we are all already, no, like we are not going to explore because skipping is not um giving us any better. Actually, yeah, I should see that. So after 8, length is plus like one more. one grade. Now hunting down. State now. Mhm. And when we skip, our length is one more and hunting down same index. So we literally examined each cases. Like we have one case, but we we went forward a level. We went, two steps forward and see what we have, and they are same identical features. Skipping bought you nothing. So taking eight is never. Oh my gosh, like like to be able to say such a thing, like you should be so confident and arrogant. All right, why? Because like we may have some another case, all right, maybe like a not two consecutive positives, but maybe two consecutive negatives, all right. So this is not valid because like in this question it may be valid, but in some other questions it is not, because I've seen some grid problems where um you know we literally try and observe different cases, and we come up with an idea based on those different cases. The general version, the exchange argument, the universal greedy proof move. Take any optimal answer that uses some later same direction instead of your first legal. Oh my god, swap it for your earlier one. Still a valid wingle. So an optimal answer that agrees with the grid choice always exists. Grid is optimal. Should I prove it? I'm not a mathematician. There are three tires, and you only owe tire two in an interview. See it, the no regret gut feeling. Taking it now blocks nothing later. Always do this. Justify it in one breath. Yes, the exchange sentence. Yeah, yeah, yeah. So like I really like the like a this term. This is the exchange sentence. Yeah, yeah, yeah. Any optimal solution can be rewritten to use this choice without losing length, so it is safe. This is what all right interviews want, not induction. One or two sentences. So formal proof, written exchange, induction. Oh, exchange or induction, guys. That's nice. Induction. Only if they explicitly put. You are not expected to write a formal proof. The expected proof is state the greedy choice, one breath why, code it escalate to the exchange argument only if challenged. So let me copy here. So yeah, so easy part, options unclear, but dominance is visual. Yeah, hard part is move the shorter role. So internal scheduling, dominance trivial once sorted, picking the sort key early is finished. The wiggle, options trivial, yes. The dominance for finding the carrier state. Hmm. Now can you create a timestamp note in our website, all right, about this. And also I still have some questions about the greedy proof. So in in the text part explain about greedy proof, yes, and also generate some pngs, all right, about like a showing, because like you showed me literally one case, all right, one case, I mean positive 8 and positive 9, but I had some greedy problems, all right, um where you literally need to carry mm, worry about or care about different cases, but you literally give me one cases and you show that you like look at the sentence you just said. So you said that identical features skipping both you nothing, so taking positive 8 is never worse, it dominates. So um like to be able to say this, you need to be confident and maybe a little bit arrogant or something, or because like coming up with this and making sure is not easy, all right? And you made it look like easy. We don't by only testing one case. So I need some PNGs and create a document using, not document, but how should I call it, by the way? Create an entry in our you know VPS for our current string. So it says it has some dominance. Yeah. So we literally have two branches, guys, and we literally say that this is this is superior. This is we literally say this is superior. Oh, my phone died. All right, let me charge it. So we literally say this is not a good option. I mean, you can explore, but you won't get anything. But here, like if you explore only this one, when valid, like this is something, guys, like when valid, exploring this option is kind of cool. Um, like this is great. And also like the another thing I wonder is, guys, uh, like we I mean not this part. We don't do like a starting fresh kind of thing. We are not doing, yeah. So like skip and start fresh. I think the reason why we don't have this is because we are, I don't know, guys. Like I need a reasoning behind this. Like we are trying to create a subsequence, right? Um, I don't know, guys. Why starting? Like why don't we explore this? Because maybe there must be a reason, guys. There must be a reason. I'm gonna ask this too. All right. So another question is like, I thought, oh, Hungry Hippo, oh, boy, back on the great algorithm second. Yeah. Today we are, solving Wiggle subsequence. Um, and our next question will be the, oh my gosh. First, I need to, and then we're gonna solve the Dota 2 Senate. Like I've studied this question before, but I understand anything. I understood nothing basically. Um, so we're gonna handle this greedy topic and it's all subtypes basically. All right. Welcome in, welcome in. How are you doing? Um, so let me open this one. History. All right. It doesn't have. What was my question, guys? So yeah. Like I need to ask this. I need to ask this. So another question is that like previously I thought about when the non-alternating case for the non-alternating case, we should like we have two options, skipping or starting fresh. All right. And for alternating case, we only one option, which is no regret. We should include it basically. But here what we have done is quite different. Like you are telling me that you are telling us that we have two options in every case, right? Include or exclude, and it is the game of rule of the game. Basically, you are telling me this, but let's say we we understood it, all right. But now like I want to understand why we don't do anything, something like a starting fresh, all right? Because the beginning of our subsequence might change the result we get, but I guess this is because the way we explore, like including and excluding. So we basically, but also we do greedy, so we collapsed skipping part, so we don't start fresh basically. So could you please clarify on that? Um, Been job hunting for any job. I need money. Yes, I lost hope in the software job market. Yeah, like the more I lose hope in software engineering job market, the more it triggers me to study lead code actually. Like I navigate my anger to lead code because like I have got some interviews actually like before maybe a couple of months ago. I'm, and even before that, I know anger lead code. um I know what they ask, and I failed in a couple of interviews, so that's why I tried very hard to grasp the idea, like a greedy idea, backtracking, and dynamic programming. These are my priorities basically. For the remaining part is basically knowing the technique. Basically, it is kind of a little bit easy. Knowing the technique and knowing your language, choice of your language. Of course, I will study them too, but I I had a hard time solving these grid problems for a long time, and now it is time for us to finish it, guys. Um, so I guess it answered. So you were right. One case isn't a proof. Two honest ways to be confident. Way one: case analysis, finite and exhaustive. Don't test examples. Test every kind of next move. At the first legal flip, the feature can only be one of three shapes. Mm, hmm. At the first legal flip, we may have same sign, opposite sign. Oh, look at these guys. The feature can only be one of three shapes. Same sign, we take it plus one. Opposite sign, nothing left. I had all of the job hunt, few jobs, everyone wants experience. Yes, yes, yes. Like experience is the most important thing right now in the job market. They don't care about how, you know, proficient you are with the code or how, invested you are. But the experience is, overcomes or dominates other. Then you are expected to do like 5 rounds of interviews, and you can possibly get rejected after all that. It's the joke. I could switch the career like electrician, and I only have to do one interview and no networking. Yeah, yeah. Like you are expected to be, AI fluent. You are expected to know Java, Python, basically the common ones. You're expected to know lead code. You're expected to be a good communicator. You are expected to do some networking. You should have some friends from college. You should attend some hackathons. It will be great. And you should do some some sort of community stuff. um, you know so uh, let me look for a word. Volunteer, yeah. They look for, like, they also test your passion, and they are looking for the volunteer projects you attended. Let's see. So take is greater than skip in every case. That's the proof. Mm. Way to exchange argument. One swap, all case. I like this idea, man. Yep, it's one of the only jobs where you have to prove you can do your job by programming and studying lead code. Nobody tests a doctor's skills or lawyer's ability to be a lawyer. Yeah. But in that area, like if you, you know, go further, like having a good experience also um, may make you get even better job. Like if let's assume you are a doctor and you're, uh, in your, experience, they say that this doctor is good. So it will help you. and all the layoffs too. Yeah, yeah, yeah. So we are going through different times, you know. Yeah, yeah. Like it is not guaranteed, basically. All right. Um, like it also has its own I'm over it. So it also has its like it provides some advantage. It gets you some advantages too, like a working from home. You know, is a literally good advantage, or working like a hybrid or something, or to be able to get a job in another side of world is a good thing. Um, so you can literally get a job from anywhere if you know that language and if you know the English. So it opens some other advantages that other jobs cannot give you. Um, so it gives you some freedom. But you know, in last 3 to 5 years, things are changing drast- drastically, drastically. Um, but the best way, like for me at least, the best way for us to position ourselves is to get, more confident about what we know actually. Like I know my weakness. I know my, where I am good at, where I'm bad at. So that's why I'm studying these algorithms. Yeah, but getting there is the hard part, almost impossible. Like let's hope for the best, you know. Let's study lead code, let's learn, let's build real projects. Um, let's attend some hackathons. Like there's a website called DevPost, and there are lots of hackathons there, and like we can create a team actually together, and we can attend those actually. Like winning a global hackathon, you know, can um, can help you getting a job even. Not a formal induction, just the one sentence. Any optimal solution can be written to use this choice without losing length. So, all right. Deliverables. All right. So we have. Hmm, so I really like the exchange argument, guys. I mean, we can literally create new each cases. Um, but this seems both easy and more promising, actually. One step, okay, is take any optimal answer, any optimal. If it used a later same sign diff, swap it for Griddy's oh my gosh, like, alright, so I need a visual about this because I liked this very much. Like, because I don't want to think about these, all of the different cases. Like, I don't want to do case analysis basically. Like, this is not the way we do, guys. We are not a robot, we are human. The exchange argument shines basically, all right, because it's both more elegant, more professional, and more valid. Like, of course, like, it is not more valid, but it gives you what you need with less effort. Like, um all right. So all right, so I need some clarity about actually we have exchange argument. Let me it created a visual for us, guys. The exchange argument. Um, yeah. So one swap beats infinitely many cases. Look at it, guys. Look how elegant it looks. You know. A run of consecutive differences. Yes, yes, yes. The positive, positive, negative, positive, positive, negative, positive. So what are we swapping exactly? Both are the same sign. So swapping zero zeros later for the earlier still alternates with its neighbors. Hmm. If I optimal O picked this, repeat the swap for every disagreement. an optimal answer identical to greedy exists. Greedy is optimal. One structural argument covers. Oh my gosh, like I don't understand this part. Let's read the answer. Actually, like the website I mentioned, Hunger Hippo is um like this one, you know. Like there are lots of hackathons here, and I wanna join them actually. I wanna attend them. Um, but since I'm doing lead code nowadays, I don't have any mental energy left for any other stuff. But like we can manage or we can arrange some, you know, team and we can join. All right. The price is quite high, and imagine you earn like you complete a hackathon. Like you learn a lot, and also if you know get some um not order but let's say first, second, or third, you know, mm, it will shine. It will make your CV shine, basically. All right. This is another way. Um, so excellent question. You are circling the exact thing. Start fresh felt like AI hackathon. Oh my gosh, you don't like it? Like you are creating agents basically. Um, Start fresh felt like it vanished. It didn't disappear. It was never separate option. Oh, nice. I absolutely hate AI. Oh my gosh. Why? Like we are using AI. Like now it teaches us. It teaches us. I like AI actually, you know. I mean the usage of AI. The internals or building, I don't know. I don't have any experience in those areas, but it is useful, yes, but it's also done so much damage to job market. Yeah, and it will do more. So we need to position ourselves carefully. Yeah. And they say that we need to focus on the human part, human side of jobs. CEOs looking for every chance they can get to replace you with it. Yes, yes, of course, because you know, cost. You are like their goal is to you know reduce the cost. So that's the logical step for them, at least. The cadence construct. Start fresh comes straight from maximum. Yes, yes, yes. You listed. All right. So it is great that you mentioned. I mean, about start fresh is already inside ink.xcode. So in our website, please create a new entry for our problem with the timestamp and add these there too. Like I really loved this idea because it seems it's vanished. It vanished, but actually it is not. Um, Add these clarifications, like two clarifications there. I really like them. How about we reduce cost by replacing management with AI? Yeah, you are right. Um, like the place we go, the place we are going right now with AI is that because imagine you have a AI and it controls your company. I mean, it directs, it suggests, it recommends some path. I would pick AI CEO, you know. Um, even countries should do that. Not now, but even countries should do that. That's why I thought of becoming an electrician or something. Job security can replace, like everything can be replaced by AI, but some of them will take a little bit more time than others. This is like the part where like the thing I see with AI is like AI cannot teach you right now. Like it cannot create those, you know, connections in your brain. So maybe like teaching and the communicating is still work. And this is why I really like streaming on Twitch. Like I'm real, you are real, and we are like doing some human connection. Um, This is valuable. So you can check the notes here, guys. Let me open them here. Let's see what we have. All right. Actually, it would agree. Yes, so we have the name of the question. Wonderful. So the another important thing, the exchange argument. Yes, is one structural swap. Yeah, yeah. So I need some images or some sort of animations. All right. So now for the exchange argument, please use like a three blue, one brown open source library and create an animation for us because I don't want to do case analysis because um, there are some parts, there are some parts, there are some grid problems where like doing case analysis is almost impossible. Um, so that's why like exchange argument idea, like approach is the one I want to learn more. And could you please create an animation where you show how we are applying this in this question, all right? And also like the thing with like the part I don't understand with the this exchange argument with the example you just gave us is that I guess it still needs some sort of case, right? Or different cases. Um, but not too many, I think, right? But thinking or evaluating or applying this exchange argument approach on a single case, I mean, is it sufficient or uh, is it is it all right, or do we need to have some different cases? Like, this is what I'm asking. So I need a answer these, and I need a animation. I need an animation. Not electricians and other traits. AI cannot do physical part. Yeah, so like it has some hard time with the physical world. I agree. I agree on that. Like human connections, quite important. Communication, and like I try to focus on the leverage side of AI because like this is leverage because I created this application where like I couldn't do this without this application because like I really love pasting images. I really love collecting images, videos, and text in one place because I don't like using Word or Obsidian or Notion or any other note take application because I take lots of images, all right, and pasting images in those note taking apps is terrible basically. And I can add captions, I can add audios on top of these each images. Like there is no end for the depth of these. Like I can see how many have them, I how many of them I have. Like this app is crazy. Like I created this application using AI. This is something I created this, for example, on screen timer using AI. And look how beautiful it looks, all right. um so um like this is good, guys, this is good. Like, and I use AI to teach me. What is that type? Yeah, it is useful. I just hate it because I think the bad outweighs the good. Like I'm trying to make um AI outweighs the best side. Let's see. Like it is dangerous basically, and nobody knows how the next 2 years will look like, or next 5 years. Nobody knows. Even Neat Code 1 year ago, even Neat Code himself said that like AI does not, like AI cannot do this, AI cannot do that. Look at it. I'm gonna ask an algorithm question and it will fail, and it was failing back then. So also he showed a website that he created. Like AI can create some bad code, bad spaghetti code, but it cannot build what I built. But now it can, and it will do better. So we need to focus on Like we shouldn't focus on whether AI will be better or not. It will be better. The cost will decrease most probably, I assume. But the part we need to focus is how can we leverage. Well, 4 days ago, Space Element's Eckhart Korea, I heard it. So Curse is probably going to be ruined. Yeah, it might be. It might be. Like the other one, Windsurf is also Eckhart by ChatGPT, I think. Like I used Windsurf for some time, like maybe 1 year ago. They ruined Twitter. Like I don't know. I will um, start publishing on Twitter too. I don't like the name. Its new name. X. What is X, man? Um, like nobody knows the future, but I know. What I know is, if you are good, then you will perform and you will get good. You know, no matter what, it doesn't change. The critical thinking doesn't change. Doesn't go anywhere. Being a good communicator doesn't go anywhere. All right. Um, these are fundamental. Fundamentals don't go anywhere. So these are knowns, and there are lots of unknowns. Like I hope for the best. I study more, and I'm curious about the future. But if it is hard, like compared to 2 years ago, like I could like I would have I would have I would have I would have been in a position where like I get lots of job um interviews, let's say, 2 years ago. But now the it is not that much. The name is X because Elon Musk is obsessed with the letter X. He originally had a bank called X.com, which later became PayPal. Oh, I see. I see. And also he has a child, right? X. I get it. I get it. Like it doesn't sound good. Like Twitter sounds good. I pity the child. No, he pities us. Let's see the animation. Let's see what sort of animation we have. Let's make it even bigger. So a run of consecutive differences, only the sign matters. Yeah. Grid takes first legal, so optimal. So G, or an optimal solution that picked. What does that mean? Later plus. What does it mean, man? A later plus. First place, so this disagrees with greedy. Imagine when that kid goes to get a driver license. They won't be able to enter it. They won't kill you. Yeah. Like, how do you type X? Yeah. Oh, yeah, yeah. His name is not X, but that. Yeah, yeah. Most probably he won't need it. He won't need it because he's gonna have some privileges. So uh, they can create some edge cases for himself. Like I don't understand the G and O here basically. Swap O's later, get these earlier. So I need to figure out what is O, what is O's later, what is greedy, what is greedy's earlier. Um, yeah, they are. Yeah, yeah. They can do. They do because they can. Um, so thank you for the animation, but still I don't understand because I think I don't understand how we represent greedy choice. I mean, you say that greedy takes the first legal. I can understand the legal part, all right, um, because um, We have some validity check, right? The rule of the game, right? um but how about O? Like, what is O? Like, any optimal solution that picked a ladder. Like, the plus means the um sign of the difference, right? In the animation, you are showing us differences, but I don't understand the O, right? Um, and we start from left, and we say that grid takes first legal, and we like in this case, we are evaluating a legal movement, not illegal. This is important information too. So for exchange argument, I should like we should think about legal movement, right? Legal option and legal option and optimal solution that picked a later product. Like, could you please clarify on that? What is O? What is G? How do we do that? Now I'm trying to understand how do we determine a case where we can apply exchange argument and where we do where we make a dominance proof, where we do dominance proof exactly. So I learned that exchange argument is the way for us to prove like a dominance proof, make a dominance proof. But now we are focusing on how, like I'm focusing on how it's talking about G and O. um and it is also talking about swapping. Repeat at every disagreement, O becomes greedy. Greedy is one concrete example proves nothing. One generic swap on a variable covers all cases at once. Like, look how elegant it looks, guys. Like, if we understand this, it's gonna be legendary. So, it's gonna be three. It's gonna be 3 hours. Good. You have found the real gap. I never told you what a solution even is. Let me fix that with concrete numbers. Actually, I don't like seeing concrete numbers either, because O and G are not abstract, they are two actual subsequences. The missing definition: what is a solution? A solution, one complete Wiggle subsequence. An actual list of chosen elements that zigzags up and down, or on the diff strip, and that's a chosen subset of. Alright, so G is Wiggle subsequence. Mm, grab a cell. The moment its sign flips the last grab sign. Any longest Wiggle subsequence. Alright, guys, now I'm gonna take a break. And when I'm back, I'm gonna understand these, alright? So let's let's pause it. And what time is it? Alright, almost 3. And we can take a 45 minutes of break. Let's see, guys. 45. See you after the break, guys. Alright. Hello. So, I guess we are back, guys. Now, we're gonna continue with another amazing problem, right? Because, like, to be honest, guys, I really enjoy. I really suffered. No, no, no. I really enjoyed. Like, look at this, guys. Like, not one, not two, not three, but four different, let's say, enlightenment points that we've got during solving this question, which is amazing, which is wonderful. Um, Let me. All right, um, so the last part I didn't get was, I think, something about starting fresh. So basically, guys, summary is, we, like, in this question we have two options, two clear, determined options, nothing more than that. All right. Um, and also we prove, and also we, like, one thing, one of the most important thing is determining your choices, and also the second important thing is um, seeing the difference between pruning versus rule of the game. All right, this is these are the two things that I understood, I extracted from this question. And also maybe another thing would be the idea of exchange argument. I think this is shared among all graded problems. Like, I didn't understand how we do it exactly, but we're gonna focus on that later because I wanna now focus on another thing. All right, all right. Let's continue with the next question. So we've seen this question before. Now we're gonna study again because, like, I didn't understand, guys. So what is the point of skipping if you don't understand, right? So thank you for your cooperation, Sergeant. Um, Now, as a private, I need you, as a commander, I need you to, like, teach us this problem, all right? In this problem, um, uh, like, what should we do? And, like, what are our options? And what is exchange argument? And so, like, can you guide us, please? Yeah, hungry people. What is this wrong? Like, I recently I'm watching some shorts on YouTube about Warhammer. Like, I like action, and I like the trust and hard work and dedication between soldiers. You know, I like those. Maybe I can study some terminology from those movies and series. Animations. Um, like, I love epicness, if it is a word. I love epic things, basically, right? um Not exaggeration, but the epicness. All right. Uh, it is something that excites me, right? So, all right, so now we have, I don't know, guys. So I thank you. Thank you, Sergeant. But I don't want to read what you have just said. I want to see what you have just said, right? Could you please create some PNGs about the description of this problem? All right. Don't show us the immediate. Don't show us the literal, a literal answer or something. Even don't give us any hint right now. Just describe what we have right now. All right. As long as it doesn't get weird, if you start role playing AI as your secretary, I will. All right, all right. So, um, yeah, we can try role play too. Like, I mean, I can create a skill. that will make Cloud some sort of character from movies, from series. Like I love Breaking Bad, Game of Thrones, Dexter, right? I love Ben 10, like and Beyblade. What else? Like these are good, you know. And Death Note, you know, as anime, as an anime. Like I love those. Bakugan. They are old, kind of old, but so on it. Describing the problem visually. No, let me set up. Alright, alright. So while it's doing that, let us read first the rules naturally, so we are on the same page. So um, you need to get it to speak the response in a voice, so you could have like an actual idea. That will be even better. But the thing is, like the thing with that, like currently we have this amount of words, this text basically. If AI will try to read it right out loud, that wouldn't understandable for me either. But maybe for some cases, oh, I have an even better idea, guys. I can create a Twitch bot, all right? You can run some commands, right? And you can trigger some voice or some replics, right? Some sentences from movies, series, all right? Like tonight, I will build. All right, all right. Yeah, that could be. Thank you for like like a TTS. What is TTS? I guess yes. I mean, what is TTS? Text to speech. Yeah. Text to speech. Exactly. Um, yeah. I mean, I mean, let's say we can have, let's say, work harder. Let's assume we have a command like this. All right. Like I can create some commands for the viewers. All right, for you guys, and you can run those commands as you like, and we can hear the sound in the stream. I want that one to yell at you. Yeah. Yeah, like the one that punishes me or pushes me or makes me more motivated. Like we can create those. Yeah. For example, imagine I'm trying to understand something and you are telling me that focus more, or are you stupid? Why don't you understand this, soldier? Continue, soldier. Something like that. Yeah, we can we can arrange. That will be fun. Yeah, thank you for the great idea. Like it's gonna be fun. Like we can, like I can generate those audios. Like there are some websites to generate those text to speech. I can create some teams basically. Let's say the Lord of Rings, right? And um you know Game of Thrones team, Harry Potter team. Um, but maybe I should also maybe think about the copyright issue. I don't think I can I can I should search about the copyright thing, about the common characters and their voices. But other than that, we can generate our own voices too. So yeah, we can. It will be fun. It will be fun. Like I also like created this website for, let's say, like here, as you answer you get some point and I store your answers in my local database basically. So even let's say after 30, like 1 month, 2 months, still we will have a graph showing the performance basically of the viewers. It is really fun. It is really fun. We're gonna do it. So AI generated an image for us, guys. Let's look at it. Senate. So let's first read the question, guys. Like, even the question itself is ugly. I'm sorry about it. Um, yeah. So Dota 2, we are in Dota 2, and we have two senates. Like they basically ban. All right. So imagine this, guys. Like I've seen this question before. I've seen this question before. So imagine like a R senate, like a X, all right, and Y senate and X. So we start from here, and that X senate can ban the consecutive item. No, any senate, all right, in the queue or in the place, in this place, and that banned senate won't be able to vote again until the end of the game. All right, basically. So let's say the turn is now on X, it bans this Y, or it could he could ban this Y too. All right. So um, I also update the question. I mean the topic. Topic is now Dota 2 Senate greedy problem. All right. So he can ban this Y or this Y or this Y. So these are options for this X Senate. All right. For Y, I mean, yeah. So in the next turn, he can or she can ban the next opposing Senate. Let's say it banned this one. Hello, Aymanat. Welcome in. How are you? How are you doing? Today we are solving this. I mean, now we are solving Dota 2 Senate problem, and we have 38 minutes left to understand. I'm good. How are you? Thank you. Like I'm doing, I guess, okay. In what language? Um, in Java. I mean, like currently we focused on the logic part. We're not typing the code exactly because typing the code is the easiest part for me at least. But we are using Java. I mean, um, let's see. All right, so let's see the image. So we have Radiant and Dire. What is that? So index at index 0, index 1, 2, we have these senates, and senators act in this order, left to right. Yes. Only active, not yet banned senator take a turn. This is the definition. On your turn, you may do one of two things. Oh, that's nice. Actually, on our turn, on my turn, I can do only one thing. It is banning. But here it says you may do one of two things. First one is banning an opponent. Pick anyone's senator of the other party. The second move, declare a victory. I haven't thought about this, guys. Allowed only if every remaining active senator is your party. All right. A senator takes exactly one of these per turn. Banning is the only way to remove rivals. The goal, and the one thing left to figure out. All right. On the one thing, yes. Um, Everything above is a rule book. This is what the problem is. So every senator plays optimally for their own party. So all right. Um, the open question: a senator may ban any opponent, but which one should they ban? Yeah. So here the winning party is Radiant because since we start from left to right, I mean, since we start from left, we ban the Dire, like the Radiant R bans D, and when it is time for D's turn, since it cannot vote and all the remaining party is R, it announces itself as winner. Here, the dire wins. All right, so let's see, guys. Let's see. So as I said here, for example, since we start from left, right? For x, it has all the y's. I mean, non-band, not band y's as its options. All right. So now, for me, like if I try to draw a decision tree, that will be hard for me too. And now I remember what Karkus said, because in our previous stream, guys, one of our viewers, Karkus, T Karkus, like in one of the questions, I tried to draw um, a decision tree basically, but it was too hard, because as we go one level deeper, our options were changing drastically. All right. For example, like this. So, like I cannot foresee which options that stake frame may have. So, and he said that he or she, I don't know, but let's say he said that um, there is another parameter, there is another information that you can make decisions by using of it. So instead of you focusing on all the different decisions, instead I have shifted my focus to another information. It was something like, difference or something, I don't know. It was most probably the stock, buy and sell stock tool. Here I feel I sense same thing, right? Because we have options for x, we have, I mean, choices for x, we have different choices for y, and depending on the previous choice of x, actually previous senator's choice doesn't affect in this case because it's opposing party. But if it was same party, let's say y and y, let's say, uh, all right, this one's choice, let's say it banned this x, so in the next turn it can't ban anything. I mean, remaining options changes. And also we have two things. We have two. I mean, we have Senator X and Senator Amidala, right? Senator Amidala, not Amygdala. I mean, anyway, from Star Wars. We have X and Y's. Like we don't have a single thing. We have two things, and they're gonna make some choices. So how are we going? How am I supposed to know? How are we supposed to design that decision tree? Because in this decision tree, we are deciding for a single thing. So now I need you to create another like new entry for our question for our VPS website, and this is like I cannot draw a decision tree, all right? Because we have two things. Like we have, I call it X and Y, all right? Forget about these R and Ds. I mean, the radiant and dire, but I call it X and Y. So I cannot draw the decision tree, and like I feel like I had this before. I had this moment before in another question, and there I couldn't manage to draw a decision tree either there, and I realized that I should use another information. Like I guess the most probably that question was sell and buy and sell stocks too, all right, and there. With the help of my viewer T Carcus, he told us that we can um, focus on the difference or focus on the change instead of yes, instead of um, deciding buying day and selling day. All right, because and like we need to do this n times, all right? Instead of deciding buy day and selling day, we can focus on something else. Like I don't remember it exactly, but maybe the increasing days, right? I don't know. But another single variable that we can use basically, and we will make our decisions based on that. We're not gonna make two decisions in each step. Like we're not gonna decide which day to buy and then which day to sell. All right, we're not gonna do that. Um, but of course, I feel like I need to solve that question again because I don't remember we've completed um, exchange argument there and proving um, um, dominance proof. All right, I kind of remember it because you know buying buying day one, let's say selling one, and we can buy in the same day we sell again. And I think mathematically it is called accumulative, right? So all right, that might be the proof for that. um but yeah, the point is, instead of deciding for these 2 days, we only care about single variable. But here I feel I sense similar thing, because here we have like a senator x and y's, but we need to, like, maybe we don't need to make it decisions for each x's and y's. All right, so I'm gonna say, like, first create that node in our website, in my website, and then on my website, and then explain. We have 28 minutes left. Time goes fast. So now create that entry and then explain. um yeah, so oh, Black Spitle Spider, welcome in. Thank you for the follow. And follower goal met. All right. Congrats, guys. We have 70 people here. Thank you for the follow. Um so like I feel like maybe, like, for example, I can try drawing decision tree for x. All right, imagine we are x, forget about opposing party. All right, we are dictator. All right, forget about opposing parties, and we are x, and these are our options basically. Right? For example, y, and for index 2, 5, and 7. All right, for that x we have these options, but we can draw, of course, from perspective of y. And let's say x, x. So maybe index 3 and 4 and 6 and 8, right? So I mean, the first y's options are these. For the second one, it is different. And also, by the time that that y's turn comes, I mean, right, the available options will change. So like, I feel like we can focus on exchange argument. I strongly believe that it will guide us. All right. um oh my gosh, what is this? Whatever. Because I thought, like, it is from our current problem, and I forbid um AI to do that for the current problem, but it is not another problem, so there is no issue with that. So all right, so our note is live. It says, let's review, renew. Hmm. Yeah. So yeah, when you can't draw decision tree, stop deciding two things. Find one way. All right, it's funny, guys. It's funny. Um, you just named a real diagnostic. A decision tree that won't throw because every node needs two coupled decisions. Yes, yes, yes. It is about coupled. Yeah, yeah, being coupled. Now, two coupled decisions is a signal. Go find a single variable. All right. That's not a those are two tricks. It's a reusable move. You remembered it correctly. You were stuck choosing a buy day and a sell day, two coupled picks n times. The reframe, stop pairing days. Look at the consecutive daily. Yes, yes, yes. The key is consecutive daily change. All right, all right, all right, all right. So here in that buy and sell question, like by this arrow, I meant that most probably, but let's say we five like $5. The price of the stock is this, and we have knowledge, like we know each day's price basically, right? The price of our stock in each day, in every day. All right. So based on that, we can calculate if it is increasing or decreasing, and sell on increasing days, and when buy. Hmm. Buying is the orator. So when we see increasing day, we get we earn the difference. We buy and sell, we get the price basically using these 2 days. And doing this for every day will get us a correct result because we can buy and sell on the same day. Yeah. So um, you were stuck. Yes, yes, yes. Consecutive daily change, one variable, and your proof. All right. Your proof instinct accumulative is exactly right. The word is telescope. All right. I thought this is some made up word. Let me copy here, guys. What is telescoping? Um, let me paste it over here. Buy day, sell day J, price, um, like a next day, current day, next day, current. Yeah, yeah, yeah. Like this, the middle terms cancel. Yes, yes, yes. It's just the sum of the daily differences. Yes, yes, yes. This is what I meant actually. So any buy sell interval, some of the daily diffs, it depends. Oh my gosh, like I love how it puts the situation we have into words. Keeping only the positive diffs can't be beaten. And that's the dominance. Oh yeah, nice. That's the dominance argument, guys, in that question. You can buy and sell on the same day is what makes diff independent. You had it. Thank you, my man. Thank you, Cloudy. Thank you, my man. Your instinct is right. Hold it. Hold it, hold it, hold it. You are sensing the same shape. Maybe I don't branch on every X and every Y. That yes, that instinct is correct. Branching on which of the many X's bounds, which of the is undrawable tree. Yes, there is a single driver here. Oh, nice. But I won't hand it to you. You are amazing AI. One Socratic nudge to find it yourself. Forget. Oh my gosh! Like, look at it, guys. Like the question. I mean, in this question, we need to know. I mean, we need to ban. I mean, the action that our senates take is really literally banning. All right. X X senate ban, like X senate bans Y, Y senate bans X, right? But we don't care about who bans who to solve this question. That is smart, guys, right? Forget who bans whom. Each turn, exactly one thing advances. Exactly one thing. That thing is index. I mean, the turn. I mean, like index or turn. Like this advances, right? Advances. Advanced technology, guys. advances. Um, and one actor is removed. Yes. So we are literally, you know, defining the situation we have. So let's say we have a bunch of x and y's, right? The fundamental thing happening here is, we have some sort of pointer, right? We have we have a pointer, and this moves from left to right, right, guys? Amazing. And as it moves, we have something else happening as well, something more happening. Um, one person leaves the island, all right, leaves the game. Um, for example, so this one. Hmm, so like for us to decide party, which party wins, we need to. I mean, the winning rule is basically having more. I mean, one party should be. No, actually, if they ban and if the game continues until one party remains, um, then the remaining pool will have only X or Y. The number of X's and Y's might vary. Alright, so if we count, so what does question ask? Given a string Senate representing each Senate party belonging, yeah. The round-based procedure starts from the first senator to the last senator in the given order. This procedure will last until the end of voting. All the senators who have lost their rights will be skipped. Yeah. So if you are banned, you are nothing. Alright. It seems like you are not existing. You don't exist anymore, basically. Alright. Suppose every senator is smart enough to will play a strategy. Predict which party will finally announce the victory and change. Alright. So output should be alright. Announcing the winning party basically. So basically, guys, if we have 3 x's and 1 y, is it even possible for y to win in any case? Actually, here no, but I now like the position is also important, right? The position of y, because let's say y is here and x is here. So it is because we go from left to right. So this is a constraint too, right? So we have like this condition and this conditional, right? We have two cases. In either of cases, y cannot win, but the position y is important. The importance of y does not shine in this case. But that is all right. So what I mean is, if let's assume we have 2 x's 1 y. All right. So or one yes 1 x 1 y and 1 y 1 x. So the importance shines here. Importance of the order of these senators. Here x wins. Here y wins. All right. So the number matters. The positions matter. Like the number and the position matters. Yeah. So what? Forget who bans whom. Each turn, exactly one thing advances, and one actor is removed. What is the single quantity that decides who gets to act next? not party, not identity. What is a single quantity that decides who gets to act next? Forget who bans whom. Each turn, exactly one thing advances one, and one actor is removed. Uh, what is the single quantity that decides who gets to act? Who gets to act? Alright, that's it. I don't know, guys. What do you say? Um, what single quantity? Like, even does the quantity have something to say? I mean, about who gets to act next? I mean, let's say we have this, all right? X bounce Y, and now it is X's turn, and it should announce I have completed it. All right, wonderful. How did you solve it? How did you solve it? Guide us. Give us some tricks. How? Circular queue. Yes, since it is round base. All right. Please give us another cue. Another trick. Yeah, it is circular. So what? I mean, AI is asking that what is a single quantity that decides who gets to act next? Not party, not identity. I don't sit with that. What changes by one every time any senator takes a turn? What changes? I mean, let's say we have these, right? And in each turn, the number of, I mean, let's say this is the turn of this X. After a turn, if R beats D, R goes to the end of the queue and vice versa. I see, but there is a step before that. Like, why should I think of queue? I see, like, this might be a solution. Apparently this is, but why? What triggers? What guides me thinking or reimagining this question, reconstructing this question as a queue? It should have something to do with this idea. What changes by one every time a senator takes a turn? So let's say turn is for this X. I mean, it was here and it becomes that. So I mean, the oh, actually, they they can vote in the next turn, um in the next round. So we shouldn't extract them after mm, turn advances, basically. Let's continue. Actually, it seems that you asked a good question, but I don't see it. Now you said you asked what is the single quantity that decides who gets to act next, but I really don't have an answer because the senators have turns, and if they win, they have to go again in the next round by putting them in the and so let's say we have this one, all right? Let's say now it is turn for this X and it voted, all right? So by Q, like I cannot do this with for loop because for loop ends somewhere. I should start over. So maybe I can use a while loop, all right? And while number of uh, x and number of y, if any of them is not zero, basically, all right, not zero, not zero. If both of them is not non-zero, it should continue. If any of them zero, it should. You have to split the dire and radians in two separate queues. You can compare them with index. Your while loop is while r or d. Yes, yes. No, like we have x and y. So if we have something to compare or vote against, it should continue. Should I draw an example? An example would be great, and you can draw it here. You can join here, draw and share the image. I understand what you say, but I also want to understand what should make me think that way. I mean, since we have R and these, right? Like there is a match between these. For example, because since R bounds these, right? There should be a connection, right? So for example, D bands R. So we should one I joined. All right, let me give you trust. All right, so you can now share images in the chat. I really don't have an answer. Yeah, so but with the help of my friend Aymanat, I realized that for each R we need an equivalent, some sort of equivalent, right? D, and for each D we need R's because they bend each other, all right? And we may use a while loop, right? And while both R and D's are not zero, their number, right? This while loop should continue. And also another thing like I learned is now I figured is we should match basically. So maybe if we have, let's say, 3 R's and 3 D's, but like now the next question emerges. How about their order? Now that I know that this we can make use of while loop, and the condition of while loop can be this. But how about the position of these senators? This might affect our result as well. So like you asked wonderful question, now explain it better and answer my this question too, and also create a new entry on my website. All right, let's see guys. So while loop idea is good, the matching case is good, but they are all about numbers. What about the positions of those senators? Because it might affect who wins. We need to like our solution should should handle this as well. Real progress on your friend's nudge landed you on the matching idea. Let me post the entry already. So let AI create that entry here. The precedent best time. All right. Why that reframe is valid? The proof I half remembered is telescopic cumulative. All right. The meta lesson I'm taking away. When a decision tree refuses to draw because everyone wants, yeah, coupled decisions, that's a signal. Yes, yes. I'm looking for signals basically. So you like I'm not so talk about told about um Q. um let's see. So my question answered properly. I asked what changed by one every turn. Yes. So what changed? Like actually the number of opposing party will decreasing. The answer is turn position in the line. All right, like this is the fundamental part. We move, we advance. The pointer walking down the queue. Why did it why did it talk about queue? So who acts next is never decided by party or identity. It is decided by who sits earliest. Oh my gosh, guys. I enjoyed reading this. Who acts next is never decided by party or identity, because at first sight it looks like party decides. No, no, it's not about party or identity. It is decided by who sits earliest in the round order among the still active senators. That position is the single driver I was fishing for. Your friend's matching idea is the other half. Together they split the problem cleanly. Quantity. Count R, count D. So basically, guys, when things go south, use count, alright? When the game ends, who wins? I posted the first one, alright, let's see. It's a bit confusing. No, no, no. So um let me take a screenshot and see. So length of senators, alright. Yeah, these are so you literally split them up. So like this was the represent. I split the two into the indexes of where they are in the list. Yeah, yeah, yeah. So like we had one representation of our input, and you you used another way of representing these in the string. Yeah. So if Arvin's append. So if the length, what does this mean? I mean, if one is bigger than zero, so R wins. Append R plus N. So R now wins. We are comparing the two first indexes of. All right. All right. So we compared this one and this one, and comparing based on what? Based on the remaining number of occurrences of their party. Like based on what we compare? Um, that index. But like I mean, we are at index 0 here, and we are. I mean, here we are at index 0 too. Okay, look, I will go. Alright. I have S. I mean, the string as yes. R is at index 0. Yes. D is at. Oh, sorry, sorry. All right, all right, all right. So I no no, no I all right, all right. I thought um yeah, yeah. So I thought these are two. I mean, they are separated, but um. All right, now I get it. Now I get it. Let me now think about it again. Um. So we have RDD. and index 0, 1, 2, and we store these 0, 1, 2 here, and we compare these two arrays. All right. R is in index 0, D is at index 1 and 2. So list, yes, yes. So D, yes, yes, yes. I get it, I get it. So the length of the senator D is bigger. No, it is not about length. So R wins. How did it? Oh, so we literally compared these indices. The diagram is confused. Let me explain it. All right, all right. We have R3. This, I think, another case. So we compare the first index of both lists. First, yes. So index 0 of R and index 0 of D. We compare 0 and 1, which is in this index. Index 0 of R is 0. And yes, yes. So why R wins here? We compare them, but why? Now we check which one is smaller. All right, but why? Why? What is the importance of these indices? How did you come up with this idea? Well, what is your reasoning behind that? All right, we compare and we make some decision, but why? Is index is really, like, I mean, that important? And by saying R wins, we say that, like, we have R and D, and since R is left, R wins. All right, because the index basically say in what order. Yeah. So we basically compared. We are basically comparing. All right. All right. Since R is on the left, it can vote the band. All right. And we are doing this for the first RD pair, because we could do this for others too. So what makes you like, I guess this is the greedy part in this question, but why don't we compare, I mean, this one with this one? Maybe R, I mean Senator R should ban another Senator D far away. In your solution, you need to prove, or you need to show me the reasoning why voting the closest one has dominance. Yeah, this is, I mean, exchange factor. Like, I really wonder how we're gonna show exchange factor, right? We're gonna do the Q dynamic, because the, now check. Yeah, so because the index is basically saying, well, yeah, the Q is dynamic, so it's just easier to compare. No, like, it is easier. Of course, it is easy to compare further indices, but this is not the reasoning behind why we choose this one. We need some sort of reasoning, because in another world, in another parallel universe, picking, the first R and the last D could be the optimal one. So being just easier is not sufficient, because there are lots of different greedy problems. All right, we need some reasoning behind it. We need some exchange, exchange, not factor but argument, exchange argument. But I like the idea of dividing this RDD, single string, into two parts, splitting in two, like a R and D's, all right, and comparing, like using, let's say, pointer 1 and pointer 2. We compare the first digits and we make our decision based upon that. But I don't know, like we don't know yet why we compare the first ones. But let's say okay. But I like the idea of splitting this into two parts. All right, so maybe I can just ask. Um, Thank you. I didn't read what you have told here, but my friend Aymanat from Stream told us that like we should divide this string into like a two parts, and using like a queue basically, but using pointer 1 and pointer 2, we basically compare the first item in the queue, like in the queue of R's, with the first item from the queue D's, all right, and we compare the positions of them. And if like we picked, the one with the smaller position wins because it has priority banning it, all right. But now I ask that, why are we comparing these two? Because we could compare some others, we could pick other pairs. So what is the reasoning behind it? Because I strongly believe that some greedy idea or exchange argument lies here, all right, exists here. So could you please clarify on that? And how would you tell us, about exchange argument here? I really like the idea of splitting our string into two parts. I really like that part, but I don't see the reasoning behind comparing the first elements and deciding based on that. Because first R, let's say we have R, D, 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 and R's, all right. First R could pick the second D, for example, not the first, not the next D. So I want to see the reasoning behind it. Um, yeah. So because exchange argument approach eliminates and shows us the reasoning, right? Because instead of doing case analysis, now like exchange argument approach is proving us, right? The round based procedure starts from the first senator to the last senator in the given order. This very, yes, like I know, like I know how it works, but let me show you what I mean. Let's say R, R, D, R, D, all right. So let's say the turn is here, right? The turn is here. So what should this R ban? Which senator D should it ban? Like, is it this D or that D? All right. You should show me the reasoning behind it, because maybe in some cases banning the later one has some dominance or priority. All right. Like we have two options. We literally have two options. Which one is superior? We need a reasoning behind it. This is what I mean. Let's see. Maybe the answer would be can be like, and also it would also be the smartest option because the smallest index has the largest threat. Because the smallest index has the largest threat. Yeah, now it makes sense. Yeah. Like, yeah, I'm looking that this kind of stuff exactly. It will also be this smart option because the smallest index, yes, has because this D, you are saying that, yes, yes. So you are saying that this D has the um, largest threat because it can ban lots of R's since it has lots of R's in ahead of it. Yeah, yeah. Like I was looking for this one. I'm not. Yeah, 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 yeah. Let's see what AI said. Thank you for that. This is the heart of it, and your instinct is right. There is dominance exchange argument hiding behind compare the two fronts. Let me show it. First, what compare fronts really is. Split into two queues positions. Yes, yes, yes. The front of each queue is party's nearest upcoming actor. Yes. Comparing these two means whose turns come. Yes, yes, yes. The smaller index acts first, bans the other front. Yeah, yeah. So real question is why ban the front D, not the second or the third D? The exchange argument. Yes, I was looking for this exchange argument because this is the heart. Um, First R acts claim it must ban the nearest D, not a far one. Suppose it doesn't. Say R bans the far D at position 3 and optimal play 0. So then the D at position 1 is still alive and acts next and it immediately ban. Alright. Now swap. Yes, now swap. The exchange. Have that first R ban the nearest D instead. Alright, so the answer is Aymanat. We suppose like we literally try banning a far one, alright? And we try like this is one case, and we try banning first, and we will say that, and we will conclude that ban nearest dominates every other choice. Like this is why, like literally it dominates every other choice. So this is the conclusion. This is the answer, by the way. Why we just compare? It is not because it is easy to compare the beginnings of the two queues. The answer is ban nearest dominates every other choice. Now we should understand um, this, trying these two, and how we make sure every other choice. I mean, how we make this true. Yeah, I was being like, but this is the core part. All right. I mean, but it is good that I mean you literally figure out, splitting. I didn't know that technique, but it is literally good. But after that level, I mean, this is the part. This is the core part. Are you doing this with one Q or two? Two. By Q we mean not a real Q basically, but an arrays, two arrays, and we compare. Um, okay, I thought I did. So now, um, so thank you for your cooperation, soldier. Um, but could you please create an animation using that open source library for like showing ban nearest dominates every other choice? Like, I really need to know. I really want to learn how we apply this exchange argument. All right, because this is the proof that we need to tell the interviewer, right? You literally explained on an example, but I need to see it, all right? Because I don't understand from words. I understand from shapes, basically, all right? Figures and shapes and graphs. Um, and also, could you also please show us without discovering every other choice, how do we like what is the beauty of exchange arguments so that we don't have to we don't have to make case analysis. All right, I want to see this here in the animation. Also, you can generate some pngs too, and also add this enlightenment or something in our vps. All right, create a new entry. I don't know if it's just me, but these explanations feel more confusing than just looking at. Of course, looking at the answer is easy part. Hunger, hunger, hippo. Like if I see the answer, oh, that is easy. Just 4 lines of code. Doesn't matter. I would say that. But coming up with that, creating that answer is kind of looking at the answer doesn't have with the problem solving. Yes, yes, yes. It doesn't. Like the answer is easy, guys. Like inverting binary tree. It is easy, guys. Like the 4 lines, literally 4 lines of code. But understanding the recursion behind it is hard. Like you literally, func left, you invert left subtree, you invert right subtree, all right, and then you invert the root. I mean, let's make them, return their root. Root dot right is x, root dot left is y, and we return true. Not true, root. So this is the answer. So what do you understand from this? What do you understand? 5 lines of code. I mean, reading the explanation, it didn't make complete sense. But when it's put into code, yeah, like sometimes I totally get you. I totally get you too. Yes, of course, because sometimes like code is the let's say gold. Code is gold basically, right? Because you see the logic here. Because since we use high level languages, all right, the logic is there when you see the code. And actually, since I partially understood this, I now made it generate animation and generate pngs. All right, like I understand some part of it, but for the parts that I don't understand, I make it generate some figures. So even the description sometimes isn't explanatory for me too. How many tokens do you have for Claude? Actually, surprisingly, like we like it's been almost 5 hours. We've used 200,000 tokens, and this is not even 1% of actually, since the 5 hour limit resets. So it is like we use like a 20 percentage out of 1 million. So it means, yeah, 200. It's not that much. So using cloud for learning purposes does not burn a lot of token. Generating code, building projects use a lot of token. And for example, yesterday I used something like workflows, and it used around 3 million token, and it consumed all of my 5 hour limit in 10 minutes or so. So using agents burn lots of token, using some skills burn token, but using cloud for learning, it doesn't require that much amount of token, luckily. But the answers it generates, it really helped me. It really helps me. And now we make it generate some images and some animations. Let's see. So answer for your question, I guess 4 million tokens for each 5 hour duration, around 4 million or 5 million each 5 hours. And for weekly limit, if we multiply with 4, let's say 4 5 20 million, 20 million times 4, 80 million tokens monthly, I suppose, around 80 millions or 100 million tokens monthly, I suppose. Yeah. Mm, all right. Oh, lazy skimmer. Hi, welcome. How are you? How are you doing, man? Welcome, welcome in. Today we go greedy. We have solved Dota 2 Senate greedy problem. Aymanat helped us, and now we are trying to understand the exchange argument part for this question, where like we literally have like a two arrays, all right. We compare the first ones, all right. But now we are trying to understand why we compare the first ones, but not the you know not other ones. There's an exchange argument and exchange argument reasoning behind it. And now we have made Cloud to generate some animation. How are you? How are you doing? And tomorrow, guys, we're gonna have 18 hours long stream. We're gonna try solving all of them basically. So like these questions we have solved before, we're gonna review them. All right, review them, and like I wanna cover all of them. 18, 18, not 80. 18 hours. I'm good. I'm good. Glad to hear that. Yeah, yeah, 18. Um, like I don't imagine how would it be. How would it be to have 80 hours? Um, 80 hours is let's go. No sleep. No man, like I could, you know, like no. It is not a good way to die. I don't want to die trying to find trying to get employed. No. It's not worth it. Like it's been a journey for us, like guys, like look at it, like we have like in our streams we studied these many greedy problems. We learned a lot. I'm quite happy about it. And like for me, the best way is first drawing the decision tree, um, and then deciding, especially for greedy problems, finding this exchange argument basically, and also collapsing, like drawing, like a typing the recursion code, and then drawing decision tree, and then see which decisions you can collapse, all right, and then exchange argument. When did you start coding? It's been, I think, 6 years or something, like in the first years of college. I graduated from college 2023, like 3 years ago. I started, coding at university, basically. Oh, we have single-threaded CPU, guys. This looks fun, doesn't it, guys? Like a task scheduler, and then this, I think, this is fantastic. Like lazy skimmer suggested to solving this task scheduler. I still didn't understand fully, but we are close. We are close, guys. Since I now know how to approach these greedy problems. Now I can see more clearly. Nice, nice. Thank you, Aymana. Thank you. How about you? How about you? For how many years have you been coding? Um, 5 years. Oh, nice, nice, nice. Quite nice. 5 years. Like which languages do you use? I mean, Java, Python, Rust. Rust is quite popular, and SQLite will be written in Rust. Like today, I've seen that news. You and Daisy said you should really practice more implementation. I will do it. I promise you, I will do it. But for example, for this problem, how much coding knowledge is required? Do you think for this question? We have we have arrays. and we compare them. We have a while loop, we have arrays, we have indices, we compare them, and based on that we make a decision. So this is not, but for example, this question does not require too much of coding knowledge. But I totally get you, lazy skimmer, because in previous some of previous questions, like we had like a arrays dot sort, right? And we were getting some like an integer dot to string. Like look at this, guys, to string, and we were like converting string a to integer a to string, and then we were comparing like a compare to, right, to into its string version of string b, right? And I guess we were like we had something like here like a and b, like I still don't know it. So like for this type of questions, yes, I should practice more. I totally get you. But also the understanding logic part is like there are levels, there are phases. Started when I was 12. Oh, that's nice. Lazy Skimmer said it's not just about what implementation knowledge required, but it's also speed of implementation while not. Yes, yes, I totally agree with you, because the first question that we have studied together, it was edit, it was a DP problem, right? Not edit distances, but um like a sibling of knapsack problem, right? And there you watched me. Oh my god. Oh my god. You watch me like doing the DP part with ease, but failing at deciding the base cases. I failed at those. So there are different phases. I mean, there are different levels, and I totally agree with you. But currently, I'm obsessed with the logic part. All right, I wanna understand. Currently, for example, I understood this question. All right, I actually not fully understand, because now we are gonna discuss about the exchange argument, right? And after understanding this exchange argument with the help of these animations and images, then this question will be done for me. I mean, complete for me. But for example, even remembering the hash maps method, all right, hash maps method, get or default, right? This is something you need to know how to use it. You need to know how do you push, all right? How do you push? How do you get? How do you I mean iterate through the keys of hash map? How do you iterate through the values of hash map? For example, I don't know. How do you iterate through the values of hash map? All right, this like you need to know this, like, and which methods we have in integer class, which methods we have in string class, um, like a arrays class, and then there were some other not primitive. So for example, what is the difference between primitive type and instance type of integer, and then big decimal. For example, big decimal, like we studied the methods of big decimal class and object oriented, like we practiced this concept here. I'm not Python, HTML, CSS. We shouldn't say HTML, but JavaScript, C++, SQL, and Lua, alright, if that counts, alright. And Hungry Hippo. Like, I really want to understand this part, but Hungry Hippo redeemed a word in Dutch, Bekvilleven gezeigt. I think this is easy, guys. Hungry Hippo. This is easy, man. Google Translate. Slap face. What is? Let's hear it. Yeah, because I know the first one. Bekvleifen Gesicht. Backfly Gesicht. Yeah, yeah. Thank you, Hungry Hungry Hippo. Aymana said that struggled with base case or like what was that question? Actually, we can open that question again. I've solved a question like a sibling of knapsack. We like I was doing some including or excluding choices, and could you please bring us some DP problems similar like belonging to the knapsack family? Because in that problem, like I figured out how to design, how to make the decisions and handle the return type. But I failed at adding some base cases. Um, Oh yeah, I remember you saying that on different thing. Um, Lazy skimmer. If you don't implement down to the level of Java, you don't know if you fully understand it. Yes, yes, I agree with you. Or at least you should think like this. I agree. I agree with you. I totally agree with you. Um, but for a long time, I suffered not being able to do anything. All right, when I see a lead code problem. All right, I failed at understanding recursion for a long time, and I failed at understanding greedy for a long time. Like I understood a binary search, two pointers, and sliding window easily, but in that techniques, I failed at the Java the code translation of those topics. All right, but for recursion, I didn't capture I couldn't capture the idea of recursion, but now I can do. Um, and for greedy problem, like a like I mean 2 weeks ago, like since the 2 weeks ago, like I don't know anything, bro. Like there are some tricks. I mean, like look at it, all right. Like there are some tricks, and should I know the trick for each problem because each problem has different tricks, all right. So I thought either I will I either I have to memorize all the greedy problems or there must be a logic. And thanks to you, you lazy skimmer, you suggested me to read Introduction to Algorithms, read that book. And in that book, I've seen something about the recursion in greedy. Since greedy problems and DP problems are both optimization problems, like deciding what your choices are is plays quite crucial role, and collapsing some of those choices to single choice, which greedy choice is the fundamental. And now I'm like the greedy problem started looking not that horrible. All right, I can do it. I will get that part soon because doing the code is relatively easy for me. The logic part I value most, but of course without one you cannot do it. So I need to be efficient on typing the code and understanding logic. Now it is time for understanding logic, and then I will switch back to typing the code. All right, and thank you for the book suggestion. I really enjoyed reading the reading the passage about greedy in that book. It really changed how I see greedy problems. Um, yeah, so it is not now unclear to me. It is clear. But for example, in this question, I may not help us, because although I know like exchange argument, although I know like a decision tree, but I couldn't figure out how to draw decision tree. And since I couldn't draw decision tree, like I failed. But I may not told us creating queues basic to arrays and comparing those. This guide us to the solution. But then also I wanted to understand the exchange argument. Now we are here. Um, so yeah, if you don't implement down to the levels of, yeah, I agree. Yes, yes, or any whatever language is. It means a face in need of slap. Oh my gosh. Thank you, bro. It's like backfly from music. It's fun. It's funny. Um, Uh, you should you should give me the problem. I guess it was this this part. We were using solving this question, right? Oh my gosh. Partial equal subset. We were like um we met Daisy Skimmer in this question. Like I could design the DP part except base cases. And we which book? Hunger book. The book uh is this one. This one. This one. The greedy part. This is good. This is good. So lazy skimmer, there is a level of level to understanding, high level like idea, concept, pseudo concept, and then there is a lower level understanding of Java code, which includes more little. Yeah, it has its own details. I agree with you. I agree with you. Uh, but I find it easy. All right. It is not that hard to know. Like we can list. So, for example, my current focus is understanding the logic part and let's call pseudo part of the lead code problems. Because, for example, for greedy problems, there are lots of subtypes. All right, and like for example, for DP, for backtracking, for trees, like I need to understand the recursion, and we have sliding window, like a binary search, 2 points, all right? And there are lots of subtypes, topics in lead code. My goal is to understand the logic, like a core logic. Let's call it pseudocode. But and then there is another layer on top of that, which is translating into Java code base. I use Java. So, which one do you think is harder one? Let's see. Look, for me, the hard part is the logic part. Of course, it doesn't mean I'm quite done with the coding translation part. I have, I know where my weakness exists, but I believe I could catch up with Java part quite fast. Um, there is a level of level to understanding, high level like idea. Then there is lower level understanding of Java, which includes more little exactly like lots of methods, like a get default method, put method. How do you insert? How do you get? How do you use queue in Java? How do you add and extract element from that queue? All right. Um, like these are important. And hanging a hippo, the part that I still struggle with is I know the patterns, but I struggle figuring out which patterns some of yes. So this is that is another layer. So when you see for example, a lazy skimmer recommended me solve a weekly contest on lead code, and yesterday or the day before that, I opened a question on lead code. All right, the weekly, and I couldn't figure which technique I should use. Right? I thought like, is it greedy? Is it TP? Like, but it was none of them. It was like you need to use Q or something. But it was not about greedy or DP. It was not optimization problem. So that's where I realized like you should know the patterns. You should know Java, which language you are using. It doesn't matter. You should know how it works, and then you should be able to recognize which method, which technique, which topic it belongs to, or it can belong to multiple topics. For example, like a linked list, and then let's say sliding window. All right, you should understand. Um, which book? Yes, there is a contest coming up in 40 minutes. You should know. Oh my gosh. All right. So I guess the time is limited, right? The time is limited. For example, 2 hours or something, or 3 hours. Do it. Oh my gosh. But if you do it, you should not stream it though. Maybe you can just stream your 1.5 hour contest. Oh, 4 questions. I heard that the last question is for competitive programming crazy people, right? But maybe the first two problems I can try doing, right? I heard the last one is quite hard. You should not stream it though. I see. But I guess I can. You can aim for the first three problems. Yeah, yeah. All right. It starts in 40 minutes, but it's not gonna end in 1.5 hours, right? I mean, I have time for attending. It is it is 5 p.m. here. Maybe like it's 8 p.m. or 9 p.m. I can attend. Um, Logic is the harder layer. Yes, in the sense that matters most. It has no ceiling, and it's the part that actually decides whether you can crack hard problem. Yes, yes, yes. Java translation, once you are fluent, becomes mostly mechanical for the common patterns. Someone with strong Java but no insight is stuck. So I hate being stuck. I've been stuck for a long time, guys. I'm tired of being stuck. All right, I'm tired. I'm sick of it. I'm sick of it. Someone with the insight can almost always get into code. Yeah. Um. So that's probably why everyone uses Python for lead code. Easier to use. Java kind of difficult with the autocomplete. Like how arraydic yeah use offer, but Python use append. Easier to remember. Yeah. Oh, ends like in about 2 hours or something. That is. Oh, I didn't know that. Oh, I didn't know that. Hmm. I guess the time. Yeah, bi-weekly. It's the bi-weekly. Oh, interesting. Hmm. Look at these guys. Let's see. To provide better content and ensure fairness. Hmm. Contest rule. Please check our new contest rule. Hmm. When should I attend this contest and when it's gonna end? I guess it's gonna start in 35 minutes, but I guess it's gonna be 1.5 hour long. Um, but is it limited? I mean, can I join it? I mean, let's say in 3 hours, maybe. Let's see, let's see. All right, so let's read it, guys. Um, yeah, yeah, we've done a good job, guys. Imanat and Lady Scammer and Hungry Pearl. Like I really enjoyed solving this problem, and I really want to understand the exchange argument, and then we can close this problem. Or you can just do this. Yeah, yeah. All right. You can do it after as a virtual contest. Yeah, yeah. This sounds a better option. Yeah, yeah. At least for this week. The contest starts Saturday. Oh, all right. It's roughly. Yeah, yeah, yeah. That means. So everyone around the world attends this at the same time. If you want your submission to count toward the official rating, you need to join during. Yes. Oh, that is good. That is enjoyable. Everyone around the globe, no matter what time zone they are in, they attend at this hour. Wow, that's good. One thing to note: you'll need to click. All right. All right. Bi-weekly. So it happens twice a month. So for the next contest, I should wait 2 weeks. Hmm. Yeah, apparently. Wow. I should. Yeah, every 2 weeks. Oh, there is also weekly contest. Yes, yes, yes. I should. I should immediately start attending these contests. Yes, yes. Thank you, ladies and gentlemen. I should definitely do this and maybe try getting some rank. All right, all right, all right. I can try solving these ones too. In the streams, we can try solving them virtually. It's a very good idea. Starting today? No, no, no. Like today, I cannot do it. I don't have energy. Um, but starting with the next week, we can attend weekly and. But Sikimur said that Lazy Sikimur said that I shouldn't stream. Yes, you can stream. Yeah, yeah, past content. But, you just shouldn't stream live content. All right. Yeah, yeah. All right, all right. Maybe like a study with me session or something that shows only the camera but not the screen. Yeah, yeah, yeah. Maybe next week we can, solve the past contests. We can do this during the streams. That's a very good idea. So now, guys, let's try understanding this part. Actually, it generated some. Hmm. We have we have something here, guys. Let's see what we have here. Ban nearest dominates. Yes. Why? It must ban 1D. Yes. Suppose an optimal. All right. Suppose an optimal play O bans 4D. We suppose that an optimal play. All right. Swap. Ban the 4D, ban the nearest. All right. So we literally try the extreme points, most probably, right? Never worse. Never worse. So ban the 4D. So nearest act soonest. Cancel early strike against you. The far the accelerator you're. Alright, so I guess this is the answer for my question. But now I'm back. Welcome, welcome, Aymanat. Welcome back. Um, so now my question is, thank you for the animation and images. Now my question is that, like, are we doing this exchange argument approach for the let's say, you, because in the animation you said that suppose an optimal play O bans the far D. So are we doing this exchange argument using like using extremes? Is this what you mean? And then now create new entries on my website. Now we're gonna wrap up and continue with the next question. Now we're gonna continue with the next greedy problem, guys, which is eliminate max numbers, not numbers but monsters. Let's see. Oh, are you not implement? No, I don't. I don't. I will um, do it later. I will do it later. My focus is now understanding the exchange argument. Um, Sharp question, and you are putting your finger on a real distinction. Short answer: no, the exchange argument is not using extremes. You are conflating two separate things. Conflating. What greedy picks versus how we prove it. The greedy choice is an extreme, ban the nearest, ban the opponent with the minimum upcoming position. That's an extreme. Lots of greedies pick an extreme, smallest, largest, earliest, deadline, nearest. That's the what. The extreme argument is not about extremes. It assumes any optimal solution O that differs from greedy. Hmm. And swaps its differing choice toward greedy's proving never worse. I think we have something meaningful here. So, what was the Fardi in the animation? Just one concrete stand-in for any D that isn't the nearest. But how does it help us? I draw the far one because it's the most visually obvious deviation. But the proof does not only cover the extreme far case. Look at two facts. Look at the two facts. Nearest X soonest um sooner than whatever's O band cancels the earliest. Alright, I will try understanding this later, guys. But this is the answer. This is the answer for how um that thing works. Exchange argument. Exchange argument. So alright, let's continue with this one. Eliminate maximum number of monsters. So let's look what we have in our website. Extreme versus extreme. Yes. So like these are notes from today's stream, guys. You can check it out. These are the lessons that we created. All right. Now this question: you are playing a video game. I mean, I don't want to read anymore. So thank you. Now we're gonna start solving this question, but now I don't want to read anymore because I feel a little bit tired. Could you please draw a PNG file describing this problem? All right, let's see. Playing a video game where you are defending your city from a group of end monsters. You are going integer array. Um, Distance of size and where is the initial distance? Oh my gosh. The monsters walk toward the city at a constant speed. Alright. The speed of each monster is given to you in an integer. Alright. Like I've seen I had a question similar to this guys during a real interview. Eliminate maximum number of monsters. Kinda this, not exactly like this, but in that question we had speed 2. So you have a weapon that once fully charged can eliminate a single monster. However, the weapon takes 1 minute to charge. The weapon is fully charged at the very start. You lose when any monster reaches your city. Any monster. Alright. I kind of get the question, but let's see. Let's see how AI will generate an image. So this is a greedy problem. So let's say we have some monsters, right, coming to our city, which is amazing, and we have a gun, right, and like let's say they go left with 3 velocity, and the um distance is, let's say, 6, I mean 6 kilometer, uh or let's say 6 vt. All right, the distance is this. So in 2 hours or 2 minutes. Let's say 2 minutes. In 2 minutes, they will reach our city. Um, we can hunt them down because let's say we kill one of them, and then by the time it will reload, 1 minute will pass, and during that time, this monster will be, you know, 3 VT closer, right? Um, we can hit again. So since there is still time remaining and no one reached our city, we have won basically. All right. Let's suppose we have three monsters, but do I mean, does every monster start from the same place, or the location also different? Different. You lose. You are giving a video game. You are giving a zero index integer array distance, so even each monster has a different start point. The location does not matter in this case. I mean, it should. I mean, it looks like it should. Where distance is the initial distance in kilometers of the ith monster from the city. Alright, they are just a distance away. Yeah, yeah. I mean, yeah, yeah. Hmm. So you are telling me that like if these are city, the monster can be this way. It doesn't matter. I understand. And so we can shoot in every direction, basically. So this is the distance. Let's see what AI generated. All right, one linear. It imagined one linear. Um, let's see. So we have an array, right? Um, let's say array of 1, 3, and 4. And 1 minute. Like we should in every minute. Now we should. So we should. I mean, our city, our soldiers should basically pick which one to shoot down. It should, like, if it shoots the closest one, what is wrong with that? Um, and each monster takes only one shot and then get killed, right? Oh, and also their speed is also like may also. Oh, all right. Now they are just this distance away. So even the distance is, I mean, speed. So now our city soldiers, guards, city watch, um, should decide which one to kill. Apparently, like they can pick the fastest one, but fastest one could be far away, and if you don't shoot the closest one, uh, you can fail. I mean, they can reach, because even if one monster reach, we fail basically, right? So how should we formulate this? How should we formulate this? So apparently, by drawing decision tree does not help us. I think you should do it based on how long it takes. Yeah, first of all, yeah, this seems quite good place to start. Um, because for example, this one will get in 2 minutes. This one will get in 3 minutes, right? All right. This one in 1 minute. Um, don't tell him that. Apologies. Let him figure out. All right, all right, all right. Uh, like we have only single formula, and we should use it. So, like at first, I thought that maybe we should pick the closest one, but then I learned that we have speed factor. But now that Aymana told us, um, we should put these two into play. So these are the remaining times, and I guess this is the answer. So um, because it doesn't matter how far it is or how fast it is, the important part is when it's gonna reach the city. All right, so this is close. All right, I'm not. If you didn't told me that, tell me that, I would be thinking again. All right. We have lots of questions, lead code questions. Maybe in the next one, but for this one, I can try typing down. I can try typing this code. Actually, we can create. No worries, no worries. We have lots of questions, lots of lead code. So we can. So for the sake of lazy scammer, let's try typing this code. All right. So basically, we have an integer array. Actually, this is too easy, man. I don't want to do it, but this distance and speed, right? Because I'm gonna calculate the remaining distance, sort by distance, and then loop, and kill the closest one. And then what? We should simulate 1 minute rollout time. All right, let's see. Let's make it this way. All right, so now we should calculate the remaining distance. We need a remaining distance array. Maybe the only part that I need to figure out is simulating 1 minute reload time, and we should during after like 1 minute reload, and we should decrease the remaining distance of each of the remaining monsters by 1. Yeah, we need to, like, I need to weigh to simulate that. All right, so maybe not a for loop. No, actually, we need to so this is distance, this is speed. We should divide distance. So distance by speed, right? Speed. We can make remaining distance equal to that one. And actually, since they are integers, we can get 0. Maybe we should use double or something, right? Because integer division is kinda risky. So let's say we have remaining distances. Now we have a while loop, and if any of them reaches to the city, then return false. If we didn't if this doesn't return false, then we return true. And the thing we count is timer. If timer is not equal to 0, we should decrease decrease timer by 1, and then we also should check if any of uh, the monsters reached. How could we check? How can we check if any of the monster reached the city or not? Like we need to do it in O1 basically. All right, let's continue. This is good. So in one of them reaches to the city, we return false. Yes, but how? We need a detection system, and maybe we can basically create another helper method, and that helper method iterate through all the remaining distance. So decrease the timer by 1, remaining distance. So maybe let's create another helper method, and we are not inside a method. Let's copy this part. All right. Let's call it func and helper method. That helper method will return us, not return us, but maybe manipulate. So it doesn't return anything, but let's make it takes a reference of distance. Yes, and helper method we can call it as you know, drop by decrease by 1. We can literally create a for loop, and we can decrease the distance by 1. But the thing is, if the distance is 0, then we shouldn't do that. Maybe on that specific case, maybe we can make it a return integer, maybe even boolean. If we try to make something, if the current distance is maybe 0, then we should return false. All right, and otherwise we can return true. So this is for decreasing by 1. So because we will decrease by 1 and we will make them move, we should show so decreasing the distance by 1 means moving every monster to the city, right? And if any of them reaches the city, we return false. If none of them, all right, reach the city, we return true. And since we have the reference of distance, we have, yes, this looks kind of cool. Let's see. So we have distance and speed, remaining distance. Actually, do we need like a remaining distance? Actually, we don't need to do that. How about we use only decrease by 1? All right, we decrease the distance by 1. Yeah. But which one we will pick? The decision we make, as Aymanat told us, the decision we make is the closest one. That's why we need to calculate the remaining distance, because this is for decision. This is for deciding which one to shut down, which one to headshot. So we need to make, like here we need to make this decision. But how? I is smaller than distance. Which one? Maybe we should use heap or something like that. I don't know. Or maybe create another helper to show the, closest one. We need to find the closest one and kill it. But how do we do that? How do we find the closest one? By iterating through. If I iterate through remaining distance, I can find it. So maybe I can just and I need its index, right? I need return closest. We should return tar. Welcome in tar. How are you? Um, we should return the closest index. All right, and it's gonna take integer array, uh, the remaining distance, right? And so it should have something like minimum integer or maximum or minimum, but set it to min x, set it to min max value, and when we find something smaller than that, when we find remaining distance is smaller than min x, uh, actually we don't like, let's be elegant and let's make it equal to, like, typing this fast is another thing. Math mean, um like, finding the greedy is one thing and typing is another, and remaining, oh my gosh, this is hard. So let's integer I is smaller than the remaining distance, and so we basically, like, this method basically returns the smallest one. We can have an elegant way, but this is the first thing I have in my mind. Remaining distance, we literally iterate every instance. We find the closest one, but we should extract the zero one. It shouldn't be the zero one. If the remaining distance is zero, we should skip it. So among non-zero value, non-zero distances, we picked we pick the smallest one, and we should return it, right? Remaining, which one? Min x, min x. All right. So returns the closest one at that time, and we have decreased by one. Simulates 1 minute reload. Um. So yes, all right. We have now our helpers. Now the core logic. If timer is not zero and is hit false, because if it is, like, we should have something like a his hit, and if it is false, I mean, if it is not false, but actually we have to return here. So I should check this in inside the while loop. All right, let's say we have timer zero. If timer is not zero, like until it gets zero, we should decrease the timer by 1, then we should create a timer which starts. Hmm, where should we start it exactly? Um, Not 0, obviously, not 1, not 2, but the longest one, the remaining distance. Like, how much time should, maybe it is not about the time, it is about, is it about if we hit or not? Well, forget about this condition. All right, we should have a system where it should tick by 1 minute or something like that. We should be able to shoot them down, and in each iteration we should check if we are hit, if we get hit or not, if we hit or not, and decrease. So let's focus on the decrement. How would I decrease? All right, like we have a method. um let's remove that, these. All right, we have a method, we like decrease. All right, mm, advance decrease. Actually, we need the reference of this distance, but in each iteration we should also recalculate the remaining distance. Oh my gosh, for the alive monsters we should recalculate their remaining distances. So all right, we we decrease their distances by 1, but kill the closest. So I guess we have a method, return closest index. So does it return the index, or it is not? No, it doesn't return its index. It it should it should return its index. Now we are returning to the closest distance. We need its index, and there can be multiple closest ones, right? I mean, at the same index. Oh my gosh. I cannot redeem drink water. Oh my gosh, man. I guess this is what Lazy Skimmer was talking about. Oh my god. Like there can be multiple ones at the same index. Like I sense using hip here would be awesome, because I could easily fetch the closest one, and the structure will this is actually a good question to make sure you know how to implement. Yeah. All right, like mm, I would use heap actually, but I don't know how to implement heap. I mean, of course Java has some sort of methods for that, because there can be multiple monsters at the same index. Yeah, I had to deeply think about for a minute. Um, but it doesn't matter. Let's forget about like and what is the time complexity of your current approach? Um, Imanats, or sorry, no. Um, so basically, in each iteration, we recalculate the remaining distance for all the monsters, and square for most probably, and square. We recalculate all the remaining distance. We recalculate all the distances. We recalculate the distances. Um, um, so it means and square, and maybe using heap will earn us some time complexity, but uh, I don't know how to use heap in Java. Because here, this is the point where I realize there can be multiple monsters at the same index. Like I can use this. It can return the first, um, like one of the closest ones, and we can shoot them. And so we'll exceed the time limit when n can be up to n, yeah, yeah, 10 power of 5. Yeah, yeah. I should, um, I should copy this part. How to use heap. Or we need min heap, right? Min heap in Java. I need this code. Let's think about I idea was Ayman'a, what Ayman said. Because without it, without knowing which one to shoot, it doesn't matter if I know how to implement, how to use at least heap or not. All right, I know I need to use heap because I know heap data structure. I know that it will give me the minimum, the closest one at O1. I know its time complexity, all right. I know how it works. Um, but first, I need to know which one to shoot, and the shooting, I should pick the closest one. So there are two layers, and my current focus is on deciding the logic, the greedy idea. All right, there are two layers. Don't get me wrong. So this is priority queue. So this is one line. I can memorize it in 5 minutes. All right, but I cannot understand the logic in 5 minutes. Um, but for example, it would be great if we have not integer, but is there a way to pick the closest without heap? Um, like without heap, what else do we have? Mm, in fact, heap will pick the closest in not O1. Why? I mean, selecting the closest is O1, but reconstructing it again for the next closest will take some time. And it is only again, as you say. Yes, exactly. Yeah, yeah. For the first one. And it should like a bubble down and bubble up. Mm-hmm. Yeah, I know how it's structured. Like the bubbling up and bubbling down, it takes quite time. And it takes n log n, height of the depth of the tree, basically. But also here, like it should store not only the distance, but it would be great if we know the index of that monster. Like you are correct, it is a one to see the close. Yeah, yeah. I get it. I get it. The reconstructing takes time again and again. Um, I wanna store integer and another integer. The first one will be for index, and the second one will be the part where we compare. All right, based on the second one, it should get me the minimum one, but the first one should be for index, and I will use for my own users. Like, can we build something like that? Anyway, don't worry, let's implement it. Like, I don't know, actually, I don't know without heap, which data structure would help us. I mean, heap is the best one. I mean, it literally gives the minimum. Like we can sort, like we can sort, and we can kill and then sort again. But sorting takes n log n, right? If we kill and then sort, and we if we repeat that process, it would cost us n log n time. But heap, as you say, give us like n log n. Why do you want to sort again? Why would you need to sort again? Uh, why? Oh, that's logical, because the order does not change, right? So the let's say we have that's a good question. That's a good question. Because let's say we have these monsters in this order, and in the next iteration they will move one forward. But let's say this is one, this is two, and if this is the urgency of killing them basically, and the urgency doesn't change. I thought I need to sort them again. Um, so sorting once seems enough, but I need to know the order of killing basically. All right, all right. So I shouldn't sort again. If I don't have to do that, I should just kill them. But I should have something like a used. I think you're right. The urgencies can change. Like if one monster is. Oh yeah, yeah. The speed is not the same. Sorry, speed is not same. The urgency can change. Like if one monster is faster but far away. Yeah, yeah, yeah. So I think you did not fully understand Ayman's idea. Hmm. I thought the speed is same, but speed is not same. Why would you need sword again then? Um. Let me think again then. You can think for yourself now. Um. Let's see. Let's see. Uh. So let's try. We have difference. So we said that Aymana said that the distance is important. Distance changes in each minute, and since speed is different, the position will change. So I should know which one is the closest now. I don't need to sort, but I need to run a for loop to see the closest one again, like a kill one and run a for loop again. So I don't need to sort, but I need to run. Um, I need to run a for loop basically. All right, which is on to see the closest one, because in each after each shoot, the closest one changes basically. Um, so return the close index does look good, but I thought if we have multiple ones, maybe picking the first one is correct. Why not? But here we return the closest one's distance, not the index. We should make it return the index. How can we do that? So so you can think for yourself now. No, like we don't need sorting, but we need another for loop basic, another for loop to see. I guess this is what I meant by sorting back then. Run a for loop to find the closest one, and if you do that in on loop for every time you see a weapon, will it be fast enough algorithm? Um, I guess it is. If we have n monsters, mm, now I try to remember what I said and why it took on, and now I try to understand, on for loop for n monsters. Is Are they same? Remember the constraint. So you are pushing me to. All right. So I guess we need some optimization. Like we need to do some optimization point where um to know the closest one. So you are telling me that I guess don't calculate the closest one again and again, because closest one, I mean the next closest one will not change. Yes, we thought about it. Yes. Let me write it down. The idea is, I guess the core idea here, I mean the second core idea after the imonot is next closest one won't change. Uh, yeah, we just need to kill it. We don't care about its position. We don't care about its new position. Yes, basically this simulation approach will work, but it is too slow algorithm. All right, all right. Um, all right. So the optimization lies here. So we don't need to calculate the distance again, but we should know the next closest one. Just an entity, like entity, we need to know the next. So maybe for the first time in first, I mean, with one for loop, we can find. I mean, we can set the urgency about. Oh, but we have different speed. We need to eliminate speed, but how? But the factor speed, like speed changes everything here. Um, because order changes. Do not try to simulate the movement of the monster every minute. You should think about the problem again for the from the beginning. Yeah, yeah, yeah. Let's see, let's see. This simulation idea that didn't give us a fast solution, but at least it showed me like I should focus on this part later to return the index. Like I should be able to return the index of the closest one, because there are some other questions I know where I should do this. All right, this is one thing, and simulation idea is wrong. It doesn't give us a fast enough solution. But now with the dynamic changing of remaining distance, let me. So we have some monsters. All right. For example, at this level, we should kill the closest one. Let's say this is greedy. But if this is the greedy part or the greedy idea in this question, then after finding this, we should be able to come up with a solution. Um, but if the greedy part of this problem is not this, then it means we should find another part. We need to okay, do optimization, exchange argument, and collapse. So in each level, we have remaining monsters. They are trying to get close to us, and we should uh, smartly, right, pick. And we set that closest one. Mm, it seems greedy. It is not the farthest. Maybe it is not the closest one, but most urgency. Yeah, yeah. Like we need to maybe we need some formula or some parameter about like where we show the urgency, because urgency is not about current remaining distance for that monster, but the urgency. If we, yeah, yeah, like it would be great if we have some sort of argument of parameter that shows us the urgency. But how do we define the most urgent one? How to know which one is the most urgent? Yes. And also, um, like, is it the correct way? Let's say it is the correct way, and it is the urgent. So if the question is now deciding which one is the most urgent, we can make use of the formulation, I guess, right? We have distance, this one, all right? And the closest one may not be the optimal, apparently, right? No. Yes, yes, it might not be. Imagine we have city here, closest one here, but the beyond that, it let's say it goes 10 kilometer, all right, and in next move it will hit us. So apparently, picking the closest one is not the optimal one. Um, Now what? How are we gonna do some exchange argument? Uh, so if the question is now find how to find the most urgent one, most urgent. I don't know. Closest, farthest. No, it can't be. You like? Should I extract this information from this? For you are on the right track. Keep cooking. In maybe in a 1 hour or something. All right, all right, all right. Let's not demotivate us. So the most urgent one. But which parameters should we use? Like a distance, speed, or maybe a few of them at the same time, and time. A monster can be far away, but might be more urgent. How do we know that? Because I'm a human and I'm smart to calculate the next hitting. Based on hitting. Oh, yes, yes, hit. If we have an array of hit time or deadline, yes, yes, hit time, right? If I know, which I know, um, I could kill the smallest hit time, right? And that's it. Yeah, yeah. Hit time. Yeah, yeah. Like we literally know the location and the speed so that we know when they are gonna hit. We don't worry about the middle steps. All right. But now the thing is, if we kill the smallest hit time, like if we kill the monster with the smallest hit time, all right. All right. All the time, the one thing we need to do is to have a while loop while no hit. All right, no hit. If nothing hit us, we should like a greedily basically. All right, blindly shoot down the monsters based on the order we know hit time. So I should create an array hit time. Uh, and I should have. Should I have something like counter? Most probably yes. I should increase the counter. Kill a monster. But which monster? Actually, even we don't need to know which monster. Uh, we can even set the hit time to infinity after killing a monster. All right, like something like this, guys. Something like this. But when are we gonna stop? Basically, when are we gonna stop? After killing each monster. You are doing well. You are doing well. Yes, yes, yes. Thank you. All right, let's forget, like, let's continue, let's transition into code, and let's try creating hit time. All right, and then we can focus on this counter and how are we gonna stop, and how are we gonna know if we get hit. Actually recognizing, hmm, if we create a method to recognize we got hit, then we can transition into code. This is the only remaining part, remaining important part. How do we recognize if we hit? Do we need to know the time? Do we? I mean, there is a monster coming right at us, right? How do we know we get hit? I think if the distance of that monster is 0, but in that case, in each tick, in each clock, in each counter, we should recalculate the remaining distance for all monster to know if we are hit or not. All right. For the sake of time, let's focus on creating the hit time, and then we can, try finding the logic for if we got hit or not. Calculating the hit time. All right. Um, all right. So now calculating hit time. Oh, all right. All right. Void func 2. So we have distance cpit, right? Calculate hit time for each monster, right? When they are gonna hit, in 4 minutes, in 5 minutes, distance divided by speed, basically. So then I can create hit times, right? um actually I need, we've done this before, like this one. So hit times. So yeah, we've done this actually. So we have this 4 minutes, 3 minutes, 2 minutes. All right. And 1 minute, let's say. And we should kill the 1 minute one. All right. Um, Now we should have. All right. So calculating hit times is easy. Was easy. We just divide distance by speed for each monster. Let's say 4 minutes, 3 minutes we have, and we should find in each iteration we should kill by one, and we should some sort of counter or something to know if we got it. Like, we need a mechanism to how to know if we got it or not. I don't know. While we are not hit, so is hit false. We and maybe also there is remaining monster. If there is remaining monster, we should continue. And if we didn't get hit, we should continue. So we need a hit mechanism. We need a hit mechanism. How do we know? How? This is a good question, yeah. Like, this question can be an interview question. I've seen similar question. So How do we know a character is hit or not? And how do we kill any monster? Maybe we can make the remaining, I mean, hit time to max integer value. Let's say we have monsters, they are, approaching us, and we kill the close, I mean, smallest hit time, right? All right. This is quite smart. This is quite smart. Killing those. But now, since they move, we we should know. I mean, we can have a for loop or something again, all right, to check if the any of the monsters remaining distance is zero or not. But again, this would mean we should recalculate in each iteration. But then it wouldn't be nice. So I don't know. See, these questions are good. It is why implementation practice is also good too. Yeah, even though yes, it can be annoying. These questions you are asking, like how to kill a monster is yeah, yeah. How, yeah, how to kill, how to kill. We know their distances, their speed, but we don't know which one is alive, right? Maybe after killing someone, maybe we can set its speed to zero. But again, we need to know in each iteration if we got hit or not. All right. Actually, the important part is here is how do we know? Like, of course, we can check. Like, we can set the uh, like we can set the remaining distance, but it should like we should have something dynamic here. Mm, I don't know. So we got the logic part. Now the code translation part. Like if we use heap, I mean not hap, if we use heap, and if we get the minimum one, right? But still, like heap will get us, give us the minimum, all right. But what are we gonna do with this minimum? We're gonna kill it. Then what? Then what? What are we gonna change about it? If we create a heap, if we create a heap where like a maybe like an index or something, or maybe is alive, and actually if we have a heap, if we kill a monster, we just push from our heap, and if the size of our heap is zero, then we just killed all the monsters. So heap can solve this problem, like a killing problem, because it really extracts that item. So we can just create a heap here. All right, now it solves the killing problem. But how about if we got hit or not? Like a hit detection system. How about hit? So before maybe subtracting, no, look, still we need a mechanism for hit. So, um, so let's say Like I guess it was priority queue. Oh my gosh. Like let's say let's have a heap. All right. All right. Now that we know implementation, um, my heap, not my heap, but um, let's call it my heap for the sake of time. I will new priority queue. Uh, Actually, we need integer here, right? Yo, no, we don't need it here. Um, like we can. So if there is no remaining master, now will be my heap size like this. If or is empty is empty if we have a method like that, it will be great. If my heap is not empty, uh, we can continue. If it is empty, we can mm, leave our loop and return true basically. And if we got hit, return false. um and all right, let's make it if we got hit, we can return false. um and now we should clean, so we should extract. How do we extract from heap? I don't know. Was it pull? Was it pull? um Kill. Basically this is how we kill a monster. We get rid of it from our heap, but hit detection system remains unknown. Hit detection system, how do we do that? Either we hit or empty, our heap is empty. Oh no, if we got hit, no, like I shouldn't check this here. Because if we got hit, then we return false. We shouldn't have this here. So our heap is not empty. We should keep killing, right? Pole. All right. Not quite close. Thank you, ladies and gentlemen. Thank you. So um, if we have monsters to kill, we kill. Um, we kill. And also we didn't basically push the elements. I don't know how to push elements. Maybe it is not that easy. Just copy this part above this part, and my heap dot not push. If poll, I don't know. Is it insert? Maybe it is push, right? Why not? Add. Oh my gosh. Add. Thank you, lazy. We add which item? This one actually, but anyway, just copy here. So we add. So we have now our heap, and we kill our monsters. Why do? Why are those purple? Anyway, um, we need a hit detection system. But for that, like since we got rid of the for loop in each iteration to get rid of the n square time complexity, um, now we don't have a mechanism, or maybe we don't need to calculate the remaining distance for each monster. But without it, hmm, actually, can we understand this hit? All right. Alright. Hit, getting hit means, alright, we need a counter. Alright. Start from 0, right? 0 or 1, I don't know. If um if my heap dot, how do how do we poll? Oh, peak. We have something like a peak, right? Or but it doesn't matter if we pick or not because we are gonna end. So poll would be alright too. If poll pick, yeah, alright. Let's try pick. If we pick an item and it is equal, no, it is equal or bigger, I don't know, equal to our counter, then it means that it um that monster came to us basically, right? I mean, but like I'm not sure if this is correct because this code double, oh, peak, all right. Peak, yeah, all right, thank you. Peak, like I'm not sure if it is the correct because we are literally checking if, oh, it is correct because now since we are doing the optimal one, like because I was gonna say that since we are trying, like here in this code, since we are um checking if we got hit or not based on the monster we are aiming at, monster we are trying to killing, like maybe some other monster can hit us other than this monster, all right? But since we are iterating, I mean, since we are functioning in optimal way, and if the optimal one is if the optimal monsters time is equal or bigger than us, then there cannot be any other cases. I mean, this is the best option, this is the best way. And if it fails, then others will fail too. Alright, this is the proof of the, alright. So if the monster we are trying to kill has most probably it should same. I don't know why I am using this, but I am kind of afraid. But let's make it, or but maybe it can extend. Yeah, it should be because there can be multiple monsters, and in the next iteration they can go over beyond that. So let's increase the counter. So this seems nice to me, guys. And we have a heap, and is hit knowledge now is not a separate thing. We don't have a separate cost basically because each variable costs. So we have heap, we kill basically, right? We kill a monster, we increase our counter, and we kill it again. We increase the counter, we kill it again. And we, like, you may ask, which monster are you killing? The monster that is not closest to us, but the one that has the most urgency, the most urgent one, we are killing the most urgent one. And you may ask, how do we define urgency? We define urgency by the time of total time for each monster that each of them will get us basically. Yeah. If it is larger, no. One last thing, and we need to figure this out, guys. If it is bigger, what does it mean? If it is small, what does it mean? I mean, let's say x v t. So we are looking at time here. If the time is big, that means it's gonna take so much time. So we are looking for the minimum one basically. And all right, it will increase. All right, we are doing it correctly. So I guess I would um open eliminate max monsters. Let's see. Like maybe most. Oh, we have distance and all right. It would work. Um, like in maybe in the most like in the first try, most probably it won't work. But let's try. All right. So these are solution, guys. I don't know how. Like I don't know how many minutes passed. All right. So we have defined the we defined greedy here as the I mean we defined the most urgent greedy. This seems good, guys. What do you say? Did it get accepted? No, I'm afraid. I'm scared to try. Like after this much of effort, let me once more check and then click that button. Press that button. um, so we have our heap. We add like we use. It is integer heap that might cause if the distance is smaller than speed, let's say 1 kilometer, but our speed is 5. I don't know, maybe I should do double or something. You have to return the amount. You just click run to check. Also you should change distance. All right, we have distance. Yeah, all right. Yeah. um we have speed. Yes, it's distance. Just click run and check the max. All right, just click run. um Distance length. So you said something about running. You said you have said something about submit button, not about run. Return false. Oh, our. Why does our method returns integer but not boolean? Oh my god. Return the maximum of monsters that you can. All right. Hmm. All right. We can count. But where is our here? If the counter, so it is actually timer. If the time is up, we got hit, and we should return something like counter that we have count to kill the amount of monsters that we have killed. Uh, we should increase counter to not uh, yeah. We can return. All right, now it should work. You have to return the amount of eliminate, not to true. Yeah. Wrong answer. And all right. Let's not demotivate. The output is 0. Most like distance 1. This is 3 and this is 4, and we got the minimum. Like This priority queue is by default min or maxed? Max. By default, is it max or min? By default, it was min, right? Yeah, alright, alright, alright. Uh, it is min heap. Mm. So when we should we do it? No, like we literally return, so we don't need to make a poll. Um, if my empty, if peak timer is bigger than timer and our timer starts from 0, and basically, what about we started at 1? I think we, yeah. Like timer is 0, and since the, like, I think we have a logic error here. We have a logic error for hit detection. So like time here is 1, 3 and 4, like 1, 3 and 4, 1, 3 and 4, 1, 3 and 4, 1, 3 and 4. This is time, and our timer starts, it should start from, I mean, for this case it should start from 1, but let's try. Oh my gosh, we are getting 0, meaning we don't kill, so we don't increase, so our counter is 0, and my heap is empty. Is empty is a correct method? I mean, it should be. Yeah, like we look for Java, right? Yeah, min priority queue. All right. If trace table, what is that? Trace table. Test case. Like something like debug or something. I'm not. Like we literally have an element in our. It is not empty. We add them. Yeah. Go through your code line by line and write down what it does and how each variable or iterable changes. Also, you can do some. I would love printing, and I don't know how to do it on lit code. I would love to do that. I would, for example, I would try, this one. Heap is, it's on the part of the terminal. So if I run it, where is our terminal? Oh, heap is all right. All right, that's nice. So it means that part of the terminal. Yeah. So we are getting into the, I mean, while loop. Oh yeah. So I don't know, man. Like we got a logic error in our time detection system. Yes. So the error is here. I don't know, like if it is larger than or smaller than. So basically 1, 2, 3, right? I mean 1, 3, 4 we have, and our timer goes from, let's say, 0, right? Let's make it 0 or 1. I don't know. Let's make it 0, right? And when it's 0, this will get us minimum, which is 1. Yes, yes. It like heap throws one at us. And then it will throw us three, and then four, and in any of them, none of them, we won't like we get hit. So in none of them we get hits. All right. So our timer will smaller. I think this is correct. Our timer will smaller than. All right, all right. Let's run it. All right. Print pick and see what we. Yeah, yeah. So like, now we have two cases pass. It means we have like we fixed some part of it. Oh my gosh, we return four. I mean, yes, but we are expected to return one. So speed is one. So we have one, one, two, three. Go on test three. I mean, case three is already correct. 3 divided by 5, 0. This is 0. No, we are using double, so. And this is 2. Like, counter should start from 0. And it should remain smaller than the minimum, next minimum. Alright, next minimum. So it should smaller actually. If it is, but if it is larger than that or equal, all right, or equal, then it is bad. All right. Let's try with this. Now the case 2 passes, but not 3. Oh my gosh. Like we are using double or something, right? No, we have, all right, that's why. But do we have something like this in Java? And also we have integers. So we are literally doing integer division, which is quite risky. Now this is another thing lazy skimmer told us, guys. The implementation part. How do we divide two numbers without losing, without making them zero, basically? But or do we need to do that? But apparently we need to do that. 0, 0. And also it doesn't matter if we return 0 or not. Like returning 0 is just fine, I think. Like what are we losing? This case is good for showing how implementation can have little more details. Yes. But I mean, dividing these and getting 0 shouldn't mean anything, because you can, you can shut. You start. All right. We have an edge case. This is not about the this part, but also I wonder what we have like for this part. Like, do we have a double class or something? I guess we don't, but we have. Yes, we have. All right, wrapper class for. So the issue, guys, here we should once there is double. Yeah. We all right. Like I haven't seen it any, so I thought maybe there is no one. There is not one. The idea is, guys, as we start the game, we can shut. So we should, you know, poll once before we start, but here of course we should check if the size is 1. If size is 0, like, is it written in the constraints? Do I need to check? No, no. We are make sure that we are made sure that we have at least one element, right? So if there is one, we poll. All right, then this is gonna be just fine. All of cases are wrong. Oh my gosh. We poll, but we didn't increase the counter, but we don't need that. Oh my gosh, guys. Oh my gosh, guys. You have a weapon that once fully charged can have a single monster. However, at every start, the monster walks toward a constant speed. You lose when a monster reaches the. If a monster reaches the city at the exact moment, the full charge, it counts as a loss. I mean, and the game ends. Let's see what we return. We have. Oh, we didn't increase the counter. Sorry, guys. Sorry. Sorry, not sorry, guys. Case 2 is failed. Try to figure out why case 3 expected answer. Oh, alright. It is because, like, we killed this one. And for the next one, so for the next one, there is no time to shoot. Actually, we are calculating this correctly, I suppose. But I didn't think of why the expected is 1. But we killed this first one. And for the next one, we fail. Like, and our code is, correctly handling this. Because for the next one, yes, we pick the remaining time, which is 0. And our timer is also 0. Yes, it is 0. So we return the counter. We are doing this correctly. There is an explanation in the description. Like, I don't need an explanation. Like, I can understand case 3, but why are we getting in case 2? Why are we getting wrong output for case 2? Let's see the description. No, you meant case 3. You don't mean this example 3, right? But I understand. But I should think about this case. 3. Actually, they are same, right? Yes. In the beginning, you eliminate the first monster. After a minute, this. Yes. Our code handles this. The distance of monsters are. You lose. Yes. So it gets here. But this looks like you understand. Now think about case. Yes. So 1, 1, 2, 3. Like, how we solve the case 3 but not case 4? Let's. All right. So we have like a 1. And why do we fail at case? We killed the first one. Like, an expected 1. It shouldn't be 1. Oh, we kill the first one, and then 1 minute pass, and a monster comes right at us, and we kill it again. But the rule says here it is also should count as failure. Hmm. Our code. Hmm. But actually, it handles it. I mean, but we are returning 4. How about we start timer at 1? No, it should be. Maybe we should. No, we shouldn't. I mean, kill the one and next one. No, it is not about the timer. Timer. Um. This is good. This is good. This is like concurrency issues, right? So the monster is at us. Maybe we can just add a if condition or something, right? But if mm, we kill the closest one again and again, and then increase. So for the first one, for the first one, yeah, we are doing correctly. So we kill them, but then monster is here, and we check its time, which is 1. Yes, we should return 1. Like this one should return 1, but we are continuing. Why? Timer is 1, and the element we pick is 1. It is 1. 1 divided 1 is 1. It should return, but it doesn't. Timer starts from 0. Yeah, it was 0. Maybe it should be 1. I don't know, guys. When do we exactly increase the timer? After killing it? Right after killing it? Time for some printing. Um, maybe like it should enter this, but it doesn't. So maybe we should check the timer and again, right? I want to see how timer how timer um, behave. So we're gonna see 0, right? So forget about the first, but yeah, forget about the first one because we literally killed it. So forget about that. So our code starts from here, right? Yes. So it kills it too. Yes, yes, the code is correct. The code is correct. Then the question is, our code is correct, and I understand it should return 4, but why it returns 1? That's the question now. Because code is running as expected. The question is why it is 1. At the beginning of the question, we kill but we kill at the beginning. You are playing a video game where you are defending your city. We are giving 0 indexed. Yeah. Is the initial distance? The monster walk toward the city constant bit. Yes. Yes. You have a weapon once fully charged can eliminate a single monster. However, the weapon takes 1 minute to charge. The weapon is fully charged at very start. So we start with full. So so we kill. So forget about the first monster. For the second monster, yeah, it is about when we are inside this loop, this while loop. Um, our timer is 0, and the value we pick is 1, right? But yeah, like I don't understand why we should enter this line. Like I'm thinking if I'm missing something or not. Like forget about the first monster. For the second monster, we are waiting 1 minute. So if we wait 1 minute, that monster is in our door. So basically, we need mm, a logic for the door. I mean, but our timer. Look at the for case 2. Look at explanation. Which explanation? I mean, this one. In the beginning, the distance of the monsters are, you eliminate the first one. Forget about the first monster. We don't care about it. It doesn't affect. It doesn't any effect. Forget about it. Actually, it does because we are now reloading. After a minute, the distance of monsters, yes. So you can only eliminate. Mm, So we don't have a mechanism for calculating the remaining distances, all right, because it is costly. It is expensive to calculate the remaining. Uh, but how about as we poll, as we poll, we decrease now. Yes, but maybe print what we are polling. What we are polling, like I mean, we are polling. We are polling our urgencies. So I expect to see one. Mm, so here, my heap dot poll, and maybe it's heap poll. No, do. Oh yes, if I pick poll, then we lose. We change the heap. Yeah, yeah, yeah. We share the reference exactly. Um, so we pick. So let's see what we have. I wanna see one here. Yeah, we poll 1, 2, 3. Yeah. Um, yeah, like they are correct, but let's also look at the timer, right? Let's see the timer. Like since it is costly, we don't recalculate, and the remaining. Then it means we should have some smart trick. So how about we do like this? Mm, timer. I should just copy this here. All right. So So 1 0. So like the issue, like we have one difference here, but this causes a problem. This causes a problem. So if the then we shouldn't do equal. But if we don't, then the other part fails. Like no, even we have only one. Oh my gosh, guys, I don't know. Um, if the time is our time, let's try randomly without reasoning. Um, don't think about it. You can maybe start. Um, oh, since we kill. Yeah, most probably the reason is that, but forget about the first one, first monster. We kill it. That's quite logical. Yeah, yeah. Like this must be correct. I wouldn't think. Like I thought about it. I thought about, like, I mean, I remember I asked about if it should from start from 0 or 1, but I don't have any reasoning behind it. But the reason must be um like since we kill the first, yeah, since we kill the first one, now we need a time to reload, and this represents that. That is good, that is good. And I click submit, and like, oh my gosh. No, oh my gosh, guys, we have 20 cases more. All right, at least we have huge number of cases passed. Which other cases we do have? Forget about the first one. Expected is 2. So we kill this one. Timer is 2. Time is 3. Oh no. Like we don't kill this one and this one. We kill based on the remaining time. So I should but they are integers. Alright, alright. So now the problem is about the integer division. Alright. So we have something like double as lazy skimmer. It is another implementation of the basic. Yeah, yeah. But it is common. I mean, integer division is risky. So, how do you convert integer to double? Like something like this, or something like this, right? Without submitting, how do I try? You said this before. Use test case, I think, right? Use test case. So is the result same again? I don't see any. Where is our output? Click run. Oh. All right. So we click use test case, this case, and click run. Now we are using this case, and it is wrong again. We got 1 and expected 2. This should be about double, I thought. I still think. I still am. Maybe like let's system out print. Let's make sure we are getting what we want. All right, let's click run again so that we don't submit again. All right, so column. I want to see double VC000. No. What do we see? Oh my gosh. Forget about here. 1 1 1. Oh, like we didn't. If they are all 1, yeah, they 1. We, limit to 1. So the output should be 2, but it is 1. Expected is 2. I mean, we kill the first one anyway, and for the next one, we fail because now we have a monster that hit us. So it shouldn't be 2 actually. Why it is 2? Why it is 2? It shouldn't be 2. Oh, a monster came and we kill another monster. Not the one that hit us, but another. But which one? Let's read the question again. Like, because as we got hit and we lose, but before losing, maybe kill another one. No, like, is it correct? Like, you lose when any monster reaches your city. If a monster reaches the city at the exact moment when fully charged, it counts as lose, and the game ends before you can use. So it should be 1. It should be 1. So we don't use, like, we kill. Yeah, we kill 1 and yeah, like it should. Oh no, I see. Since we do like since this is 1, I mean this is 1, but it is not actually 1. This is 1.2. So we reload our gun, shot it, and then the other monster just hit us. So this is quite close us. So it means that we don't do like a division. It is about the division, and should we use float or something? Come on, man. Like if double, or let's use it double and hope for the best, guys. Oh my. How do we? How do we? How to convert double to float in Java? Double value of like if I use this one, would it be okay? Would it be okay, guys? It is not okay, guys. How do we convert? Actually, let's make it integer. No, let's make it double. How to convert double? How about that one? Explicit typecasting. Primitive double to float is just using this one, but How about float value? We have we have but this is integer. Like in our distance and speed we have integer. We should not double, but we should have to convert integer to float. Implicit widening. We can literally do that. That is nice. How about we use like a casting right away? Why I can just use here like this one then? Speed online float literal is this one. So, yeah, I am doing that already, but like we need something like a 1.2, right? We need something like 1.2. This first. Oh, parentheses. Alright. But it doesn't matter. Like I thought it doesn't matter, but because making one of them should convert the other one as well. So to prioritize, it shouldn't matter. It shouldn't matter. All right, let me try that one too. Like at here. Now this should work. All right, this works. Yeah. All right. So by typing the 1.0 at the right, I thought I am converting the divisor part, but as you said, since it goes left to right, it first does the it first completes the division, and then multiplying with this doesn't give us any meaningful. I had this in my mind, but I implemented it wrongly, poorly. I guess we so already loses the information. Exactly. So hope for the best, guys. Yeah, it should run. Accepted. Welcome, guys. Welcome. Let me make you let me make this a little bit huge and presenter. Come on, guys. GGS, guys. GGS. Ladies and gentlemen, Rosemary. Oh my god. Like this was easy, guys. Like come on, guys. There was nothing. Thank you, ladies and gentlemen. I mean, so like, by the way, is the runtime slow because of the? Oh, let's fix it. I wouldn't think about. Oh, we are so and let's see. Printing is costly. It seems like I wouldn't guess this much cost. Just calling a function. Uh, Here is how I did without double. Let's see. Let me submit it again. I guess I copied. Oh, but it is still here. Not good. So I should. All right. Without because double is also contains some space, right? Since it's a wrapper. If it is 0, but if the remainder is 0, you divide it. If it is not, so we are dividing first and then add 1, but I mean you must uh, lose precision again. How don't you? You are also sorting time, so you don't use Q. Oh, Carcus, welcome in. IO-bound operations always come with a high cost. Interesting. I posted on the stream arena. Let's see. Um, a bad case time. Uh, Let me first look at the lazy solution. Like you sorted time. Like I don't understand how you don't lose precision. I mean, how you get 1.2 for example, or 1.3. I don't know this logic. Let's see. You sort the time, so you don't use the queue. But if you don't use the queue, how do you know which one you extracted? Answer is 1, or you start from 1. Uh, Actually, you don't need to know which one you extracted. Oh, I'm using heap here. Mm, I mean, not efficiently. I'm not so short. Lazy said, by the way, in my second for loop, my eyes is like your timer. Yeah. Because it always takes exactly 1 minute to recharge. Yeah. So like we don't need to have a heap or something. You just sort. Hmm. Alright. Using heap here is like So I just need to differentiate between remainder 0 case and not remainder 0 case. If remainder is not 0, yeah. If it is not 0, you divide it anyway, and you got, for example, if you divide like a 2 by 3, or let's say 4 by 3, you get 1. Or you get 0, not 0, you get 1, but you lose the time. I mean 0.3 time, which will have the same effect. If the remainder is not 0, it's like with double the time. It's like with double the time will be like 1.1, which will have the same effect like just making it like 0. So 2. 1.5 is example. All right. I should take a screenshot, and I should look at the this converts basically. Say the result of division is 1.5. Result of division. Yes, if it is. But can it be 1.5? I mean, if in real math it can be, but here it is 1, right? We cast into below side, which is 1. Yes, it is exactly 1. Yes. You make it 2. All right. So you basically you are saying that we don't need to know if it is 1.2, 1.4, or 5. The important part is it get it hits us. So basically we can count it as 2. Oh my, that's good. That is good. I like it. And Karkus, welcome. Could actually first let me read uh Aymanat's solution, I think. Oh my gosh, let me open uh Python example. Time dissipate. Yeah. So this is time for in when I 0. like handling these cases is something, guys. Like when it's zero, when it's gonna hit us, when I one, time is one, when I zero, time zero one, when I want. Or it goes from example, yeah, from this example. Time. So you die, you return I. Hmm. Oh, you are using a for loop, like instead of having a counter, you basically use the for loop iterator. Or that is nice too. That time, I guess you are doing this right, and so on. Past all the comparison return length of this, if it passed. That's a good way. And that's another way. Oh my god! Like even for a simple, you know, solution, we have like a three different solutions, and mine is no. Let's not demotivate that. Or you are using Python, and you just do the division right away without caring any convert, any losing precision. Uh, and if it is smaller or equal to zero, alright. Actually, we are kind of making the same thing, but you don't worry about the precision. How? How? Why don't you have to worry about precision here? I mean, does actually it is even integer. Um, Carcos said that could clean it up a little by starting I from zero in second loop. In second loop. Then condition is if time I is bigger than or equal to time. So actually I have the same thing, but I'm comparing it if it is smaller or equal, and you are telling if it is this is time passed. You are checking if I is equal or actually I remember this checking in another case actually in jump game. Yes, in jump game we have like something like as Karkus said in jump game. We don't have the solution, I guess. In jump game we do the same thing, like as we hit as the I value. Let me show you guys. If the I value is equal, then we jump basically. Jump game Java solution, and I like somehow I resembled Carcos's solution. Like I don't know, like it reminded me that it yeah. Um, return I, and in the end return time length. Time length for the case you. I don't understand that part. Let me show you the jump game. Oh my god. Give me the solution right now. Lazy said, then I just make it two. Exactly. Nice things. Yes. In Python with slash, it does floating point number. With double slash, it does all right. Like I remember, I've seen double slash, but for I thought it was integer. No, in jump game 2, guys. In jump game 2, give me solution jump game 2. In solution of jump game 2 we have something similar, like as the I hits a certain point. All right, this is the place, this is the moment we should jump, and we basically check if we needed to, if we need to do, right? I gotta go now. Ayman, thank you for stopping by, Ayman. Take care. Bye bye. Thank you for stopping by. It was great studying with you together. And Karkus said it was a reply to this code, but in general, there is no reason to declare a variable that is counting pretty much the same thing as the loop variable is already counting. So we make, like, we use the same thing for two purposes. Yeah, like it is kind of optimization. We don't create another variable. Yeah, like, and I remember this from Jump Game 2 because here, um, this line is the part where it's telling us to jump basically, and we don't need um, any other counter basically. Like we go from left to right here again, and when it is time to jump, we jump. So, um, but I thought using while loop would help us. And I used heap, and I think heap is overkill for this question. And sorting is is a good way. Where is the lazy solution again? Let me copy here. Like sorting is good, guys. Let's look at. Yeah. Like I don't need to. Actually, I do the sort thing by using heap X. Like it gives me the smallest one again. So actually, I don't need to use heap. Like heap is kind of overkill. But I thought, like since I had some time pressure, all right. I thought I have used the first thing because the using heap is a safe way, all right. I mean, it just gives me, and when it's empty, it is done. But here, when we sort it, we should also care about the start and end point, and actually look at it. Like you start from one. Like this is important. This is important. Like in my solution, I like we don't have. Actually, we have, but I started. I made it start from zero in the beginning. All right. It's good, guys. Like seeing different solutions. Um, I gotta go. Yeah, it's fine. Your time complete is still n log n since because of that's why it is slow. Heap needs its time to sort. All right. I need to use this one. But which sorting algorithm are you using? Because the best one I know is n log n. But maybe there is some hybrid. My one is also n log. All right. Because best one I know is n log n, but there are some hybrid solutions. Like there is something with there is a sorting algorithm starts with T, like a T not Timo, Timo. There was a sorting algorithm called like a starting with T, like a hybrid sorting algorithm. What was it, and what is its time complexity? Your one is slow in runtime probably because you have to. Oh, team sort. Yes, team sort. Yes, team sort. Because you have to populate heap too. Yeah. Because we at first we yeah. Like we are doing this, like this costs us something, right? Like we initialize and then populate, and then we start. All right. Nice, guys. It is enjoyable to think about the time complexity and comparing our solutions. Team sort is hybrid, but how about time best case is O(n)? Oh, its average is n log n. All right. So there is nothing better than n log n. in average. Like, yeah, so is there a better better sorting algorithm in on average that gives us better than n log n? I really wonder. Um, you cannot do better than n log n for comparison based sorting algorithm. All right. Most all built-in sorting algorithms are hybrids as they provide better average case. But upper bound is still n log n. You can do ON with some more information on it. Yeah, possibly better. Yeah. Like if it is already, if it is like there are some cases where it is increasing, it is easy to sort. I mean, or decreasing. Yeah, and it's also for example for heap sort, the approach you use for selecting pivot is also determines your time complexity. Short answer, not for general purpose comparison thing. There is one lower bound that says any sort of algorithm that works by comparing elements. This one on average. So team sort, merge sort, heap sort, and quick sort average case are all bumping against the theoretical law. You cannot beat n log n with comparisons alone. You can do, yeah. Yes, the proof is nice. The proof is nice one to know for interviews. A comparison sort can be modeled as a binary decision tree. Each internal node is one comparison. Each leaf is one visible ordering. With n elements, there are n factorial possible orderings, so the tree needs at least n factorial leaves. A binary tree with n factorial leaves has height at least this, and by Stirling's approximation, the height of the tree is the number of comparisons. In the worst case is the average case is bounded the same way. All right. I don't understand how we do this approximation. Yeah. Can you list the time complexity of these and more time complexities actually? Radix sort. So team sort, radix sort. Uh, where are we? All right. Yeah. So radix sort and team sort, right? Who is team? Cold joke, guys. Constant, logarithmic, root, linear arithmetic, quadratic, cubic, polynomial. So this is super exponential, factorial. All right, let's review it. All right. When it says n factorial, it's just saying the number of nodes n factorial, not the time complexities. Yeah, yes, but it also said something like it talk about the approximation, and there it used factorial inside. Oh my gosh, where is it? Inside the big O notation. Yes, this one. Binary tree with n factorial leaves has height at least uh, like this one. If we have n factorial number of leaves, this gives us the height. All right. since we have, what about the height is 4, total number of nodes we get is 2 to power of 4, and now it is kind of vice versa. You probably don't need to learn the proof for interview. Have you learned about binary decision tree? Yeah, yeah, I know binary decision tree. Which aspect of it you are, I mean, let's say if the height is 3, then we have this many nodes, right? Um, and if we have n factorial leaf nodes, this is the height. It says. I guess it is the reverse version of this. Yeah, yeah. Like these works, in opposite order. So, uh, it's been 7.5 hours, guys. Like it was great, guys. It was great studying together with you. Today was amazing actually for me. A journey. Um, it was fun to code and see the implementation details of this question. And actually, I feel like I'm getting better at this greedy, all right. But I will continue because um, it. I find the logic part kind of harder than the implementation part. Implementation also includes its tricks, all right, because for example, using a heap is not a good option. For example, because of since we populate basically, and also for example, like from college, the first thing they taught us was this one, but I didn't use the parentheses here. But of course, since Java, operates functions from left to right, the first operation it does is this one, and we already lose the precision, right? So it is not important basically to multiply that result with this one. Uh, yeah, so this is the correct way. For example, this. Oh, and also like today we discovered like a double wrapper class. Like I know integer and uh, integer wrapper class, a string basically, yes. But I haven't used double before. Um, yeah, for example, this is a small trick that we can use almost everywhere. And also for this problem, guys, one implementation detail actually like might be this one, like a starting timer, right? This is quite important, guys. And the next important thing is um, I think about here. Yeah, yeah, and also the solution that lazy schemer used is great. Like this is good, guys. Like we can like you can use this pattern in other questions too. Like this is some fundamental thing where like you lose some precision, um, and you actually make it even one bigger. But for this problem, for example, we get what we need actually. All right, we lose still we lose precision, but we handle it in such a way that we get what we want still. So this is good, guys. This is good. And also in Ayman's solution, like we use like in Python, it does float arithmetic basic, right? Float type, and we like as lazy schemer said, if we use like a double slash, it means like an integer division, right? And also the important thing here is yes, another thing as the Carcus and the Aymana solution, if we have a for loop basically, right? If we have its iterator, right? And as like let me read the Carcus sentence. Um, So in general, there is no reason to declare another variable that is counting. So like here, like we can make use of this I for counting too. Uh, there is no reason to declare a variable that is counting pretty much the same thing as the loop variable. As a loop variable I is already counting. So this is already counting. Yeah. So since I used heap, I didn't think of that part, but I will try solving this again using erase sort. Um, and also yes, like I really like this. Um, yes, it's mini pata. Exactly. So tomorrow, guys, we're gonna have 18 hours long stream, and we're gonna continue solving questions from here. I would just use math library and a cell float division as I'm lazy. Which math library function does that? Show me math library in Java for float division. I mean, which methods it provides us. Let's see. Thank you guys. Thank you all. Today I learned a lot. It was quite fun. So tomorrow we're gonna continue with this. Like, I will. We're gonna finish this. All right. We're gonna finish all the remaining parts, and I wanna dedicate all at most 2 hours for each problem, because beyond that, I mean, beyond that isn't efficient way. All right. Um, but tomorrow, maybe in the first hour, I will try, and I don't know, like what I mean is I will try implementing it too, because today we implemented one question and it taught us a lot of things, right? But my priority here still is, understanding greedy, but and also it gets easier each day to recognize the place for greedy. Actually, in greedy it is easy. Actually, it is easy. It is not supposed to be hard, knowing which part, which, like for example here, the trick was, the urgent one, and which one is urgent? Is it the closest one? Is it the fastest one? Is it the closest one? No. Is it the fastest one? No. It is the most urgent one. And how do you define urgent? You can define urgent one, when it reaches at you, basically, right? So this was a trick actually. You kill the urgent one. That's all. Like it is not too complicated, but there are some other greedy problems where drawing the decision tree really helps. And there are some others that isn't, it is not good to draw decision tree. Like it doesn't help. But there are some other it really helps. For example, task schedule. Oh my gosh. So for example, this forget about this formulation. Let me add it. Like, or maybe even this one, right? How was it called? Yeah, forget about this formulation. This is not the correct one. The correct one is I don't know. We're gonna review this, all right, tomorrow. Correct one is something else, guys. Something else. This is coupled one. Coupled. Coupled. This is good, guys. This is good. But the thing about this question is, we are not supposed to come up with this formulation at all. This is not important. I'm looking at the charge. Uh, the important part is in something else. All right, something else. What else? Like we're gonna do some review, hand of straits. All right, candy. Oh my god, like these questions are good, guys. Both to save people. Yeah. Like which person are you gonna pick? We need to do some reviewing too, guys. Like yeah. Exchange argument. Exchange argument. Yes. my focus will be exchange argument, because exchange argument provides you, you know, the ability not to do case analysis. All right, you don't need to try every case. All right, exchange argument tells you or proves, all right, even better, proves that this is the optimal way of selecting or choosing. um yeah, you did good to figure out it. Yeah, thank you, thank you. Like, tomorrow our goal is to finish these, the remaining ones, and review, make a general review. Quick clarification first, there is no Java class literally. No, yeah. The math, yes. So the thing Carcus mentioned um, is the floor division. There is literally a method for that. I didn't know that. Instead of dividing integers and then making them double or something using casting, we literally can use these integer division rounded. Yes, the word is rounded toward negative integer, so the left side. Um, always sign of division. Yeah. All right, this is good. This is good. Not sale floor and a few low level. All right. I don't know this. That's all right. So thank you guys. It's been a pleasure for me to study together with you. Hope tomorrow is gonna be better. Like tomorrow, at most probably at 5 a.m. I'm gonna start streaming, like UTC 3. All right, in Istanbul, and we're gonna have 18 hours long. Bye bye. Thank you for stopping by and helping me out, Lazy Sycamore. It was great. Yeah. All right. See you tomorrow, guys. Take care. I wish you a good day and night. How do we do?
Racing my own thoughts into the silence, seeking the guidance I